Hi everyone, this is Dr. Aeronautics. Welcome back to episode 7 of 8 on our Saturn expedition. We've visited Saturn's atmosphere, Saturn's rings, Enceladus, Titan, Iapetus, and our itinerary has come to an end. It's time to go home. And we planned it that way, so that's exactly what we're going to do. We are here at the summit of our journey on Saturn's farthest out round moon, and we're sitting on the opposite side of Saturn than the Sun is, so this is really as far as we're going to get. So what we're going to do is we're going to plan our trip. We're going to get into an orbit that is going to allow us to get closer to Earth's inclination, and then we're going to sit in orbit, go around Saturn, and while we're doing that, we're going to figure out how long we're going to sit there in orbit before it is time to come home. So we'll start with the ground cockpit startup checklist here. So we're going to check the damaged systems using keys 4, 5, 6, 7, and 8. We're all green. So now I'm going to test some warning lights. Test panel 1, good. Test panel 2, good. And test panel 3, good. Alright, so we're going to power on our MFDs now. And we're going to plan the trip. Okay, so I've got it now. What I did was Iapetus target Earth. So now you can see current inclination 35.53. Earth is at 3.29. So if you take a look at the graph here, you can see that the difference is 34.9 degrees, and it's increasing. So what we're going to do is we're going to wait around until we basically go around Iapetus long enough that we hit our bottom, because what's going to happen is our relative inclination as we go around Saturn will look like a sine wave, and we're basically waiting for that to get as low as it's going to get. And once it does, then we're going to burn, see, I think it's southwards, and burning southwards will get us into a polar orbit that we can then use to eject into a even lower inclination orbit around the Sun. So we're going to wait until this bottoms out. Okay, so we're there. We got 20.56. Ooh, now you can see Saturn is backlit, and you can see the rings too, which is kind of surprising because, let's see, if we're on one of Saturn's moons, it's usually pretty unusual to see the rings like that. It means we're at a pretty high inclination even for Saturn's equator. Anyway, so the next thing that we need to do is go to Sun, and then we're going to turn our HUD on to Sun orbit. So what that's going to do is that's going to reveal to us the directions of our orbit. So right now we're pretty much heading in a retrograde direction, and I want to steer towards an anti-normal position, which is going to be off to the left. That should help to lower our relative inclination. So we're going to head left, and we're pretty much, we're pretty much exactly anti-normal. So we can turn 90 degrees, and that will bring us in the direction that we want. So we'll go back to auto reference, HUD, surface. So let's see, if we turn 90 degrees, that brings us to 200. So that's going to be our takeoff direction, 200. And we're going to get into a polar orbit around Iapetus, and then when we eject, we're going to lower our relative inclination relative to the sun. Alright, so at this time, good to continue for takeoff, so we'll proceed through the checklist. Determine launch time. That can basically be now. It's non-time critical, so now is not the right time. It's not a problem. We'll just wait. No time skip is necessary. HUD to surface, yes. HUD color is desired. We have it as blue for the Saturnian system. Secondary HUD 3. And then we have to record the ship masses. Okay, on our sheet here, the first thing we need to do is record the V2 velocity after the stay on Iapetus. We haven't moved the ship one bit, so that's 0. The next thing that we need is our final mass, which we'll record as our initial mass, because we know 100% we did not use any fuel here, so that gives us a 0. So now we begin the ascent. This time we are going to pull the number from the ship. So the fuel before ignition that we have in the tank is 1189.8, which, yes, should be exactly the same. Then we need the initial mass, which is 29961.6. And it's different because we've stayed on the surface for quite some time. It's been a few months. That's how long it takes Iapetus to go around Saturn. So we burned mass in the form of oxygen. And then we're going to put 0 for V1, and we don't know what the numbers are going to be for V2. So just to confirm, we should have the same amount of margin, 1175 versus 1189.8. Looks like when we're done, 1173. That's weird. Why do we have a different expected mass for no... Oh, did I subtract the oxygen? I did. Let's see, how many kilograms did we lose? First, let me make sure everyone's on board. 1, 2, 3, 4. Yeah, we're all here. So we lost about 40 to 50 kilograms. Yeah, okay, so that's what that drop is. We gain, interestingly enough, we gained that extra margin because we've been sitting on Iapetus for so darn long that we've lost enough mass that we now need 2 kilograms less simply because we've used more oxygen up. That's interesting, and it's truthful. Okay, so then we take off, we get our V2, we get our final mass, and then we get the expected for the next ones. Okay, so we're done. Alright, I'm going to configure my MFDs now, so the left one we'll put to surface. The right, let's keep it on aligned planes, because I want to make sure that this is going down and not up, because if I make the problem worse, let's see, if it gets worse, I'm not going to take any chances. If it gets worse, it means that something is wrong with my theory, in which case the safe thing to do would be to eject due east or due west. It doesn't matter because Iapetus rotates at the same speed it orbits, so due west is fine for an orbit. So that's what we'll plan to do. A tertiary HUD on. Temperature display degrees centigrade. Let's see, APU on. Let's see, payload camera view. turn on some lights here. Oh, that stinks. There's no illumination of the payload bay. Okay. Well, I'll just check the status here. Let's see. The bay door is closed. Okay. So that's not needed. No cargo is grappled because we didn't unload anything. Close the cargo bay doors. Nope. Close the inner airlock door. Okay, that I can do. Well, it's already closed. Close the outer airlock door now. Okay, that's closed. And we like to keep the airlock pressurized when we're in flight, so I'll pressurize that. We can also close the nose cone at the same time.
Airlock pressure 14.7 psi.
Yep, and I see the nose cone is closed, so we're good. Close the cabin hatch. It has to be closed now because we'd be dead if it wasn't. Then we check set fuel. So just to confirm, looking at my numbers here, 3,000, or 30,000. Whoops, wrong line. 29906 1.6. Although it's actually going slightly down because we're using the APU at this point. Let's get a new mass before we take off. We shouldn't need the APU for the takeoff. So let's see. Fuel set, nav beacon, and strobe. Don't need those. AF control and RCS mode. We'll turn RCS mode on rotation.
Rotation.
Okay, no external cooling because we are in the Saturnian system.
Information. APU running.
Let's check our life support. So we've got 4,872 days, which is something like 6.5 years of flight time. So let's see, 4,872 divided by 365.25. We have 13 years of oxygen, so there's no concern that we're going to run out of oxygen. So we're good to go, and let's see, O2 is, yes, it is flowing. We have 4 crew members aboard. We took 4. So we're good to go. So that's the end of the checklist. We're going to go to VTO. Radiator is desired. We can leave that open for the time being. That's a pretty low velocity takeoff. Hover doors open, retro doors open, and autopilot is desired. We'll turn it on, but for the time being, let's turn the APU off. It's not needed anymore. And I'm just going to update the numbers real quick. So the main fuel won't change. What changed was our mass. That's going to be 29957.6. Okay, now we're ready to go. So let's go to attitude hold. We're going to engage. We're going to slew left to 200. I'm going to begin adding main engine. If I find that our relative inclination is not decreasing, then I am going to, at that point, cancel and go slew to the right to 270. And other than that, we are ready. All right, taking off in 10, 9, 8, 7, 6, 5, 4, 3, 2, arm now.
Lift off.
Okay, we are off, slewing to 200. Let's confirm. Whoa, boy. That's not doing what I expected it to. Okay, 270 it is. believe we do not need hover thrust at this time. So I've cut that off. Let's turn to 270. We're now at 1 kilometer, so we're safely high up right now. There's Saturn again. Very nice. Alright, still ascending, so we're still good. And we'll go over to orbit. Remove frame to equatorial. Projection ship and distance in kilometers. So let's see. I am targeting... I forgot to check the orbit that I wanted to get to. A circular orbit at 794,500. Okay. So in that case, let's go to distance. We burn until the apoapsis radius says 794,500. Okay, still ascending. When I hit 3 kilometers, I'm going to relight the engines and we'll go for orbit. All right, standing by, 29, 29, 50, 60, 70, 80, 90, now. All right, we're looking for 794,500. Okay, nearing orbit. 770, 80, 84, 94, 300. That's close enough. Autopilot disengaged. And that's it. So at this point, we'll turn, let's see, the APU on. We'll close the retro and hover doors. And the landing gear. Bring that up.
Gear up. Gear up and locked.
Okay, all are closed. APU off. Get into our prograde position here. And I want to circularize, so let's wait until we get up to the top of our orbit here. Okay, so we're not done quite yet. The requirement is to get into a circular orbit for us to finish our ascent. So I'm going to not take the numbers right now, and we're going to wait until we get to the top of our orbit. But first, quick save. Okay, we're now 45 seconds from the apoapsis. We should have a very short burn. To be honest, I might even be able to do this with my RCS if I wanted to, but I don't want to change up my fuel calculations if I don't need to. Okay, so we've got 25 seconds to go. We'll spend about probably 10 seconds trying to firm this up using low amounts of fuel. So we'll burn when APT gets down to 5. Alright, we're 10, 9, 8, 7, 6, and there's 5. So we're looking just to circularize. And that's it. We've done it over a little bit, but that's okay. We're 2.005 is good enough. Okay, so now I'm going to quick save. And it looks like we're on the daytime side of the Iapetus again. Alright, let's get the numbers. Final velocity is 360, looks like 8 this time. So we're little bit faster. We're going to get a little bit higher. That's okay. Our final mass of the ship currently is 29919.5. And we have, let's see, 1153.3 left in the tank. So let's see what we did with our margins here. So if I subtract the first one, I think we had a margin of 16.6. If I subtract the second one, we have a margin of 30.6. Okay, so thank goodness what we did was more efficient than I thought we were going to do. Maybe that was because I didn't burn as high, but either way, we just doubled our reserves. So that's good. Again, it doesn't necessarily mean we save anything if we finish with all of our reserves. It just means that we're more accurate. So I guess it's just like brownie points, but you know, it's kind of like funding, right? If you're given the funding, you want to use all of your funding, because if you don't use all your funding, then your supplier is going to be like, you didn't use all your funding. And then you'd be like, yeah, aren't you happy about that? And then they say, yes, we're going to cut your budget next year. So yeah, don't do that. Okay. It is now time to perform our Iapetus escape maneuver plan. Let me get our initial mass, though, for the next burn here. So we'll say 29919.5 and same speed, 368. Those numbers are just in case I forget to do it. They're already in there so that I can recover them if needed. Alright, so the way we're going to plan the Iapetus ejection is we're going to reference Saturn this time. And what we want to do is we want to eject when we are exactly aligned with Saturn's prograde, or not Saturn's. Yeah, well, our prograde velocity vector around Saturn, that increases our orbit. So basically, when the cross of the Saturn orbit lines up with the cross of the Iapetus orbit, that's where we want to be. So what I'm going to do is I'm going to switch over to HUD, and let's see. Right now, where the heck is this thing? Oh, there it is. Okay, this is the exact opposite side to be on. So in fact, we can tell just by seeing orbit Saturn here. So you see how it appears that we're on the apoapsis side? That basically means that we are facing in a periapsis direction. So if we eject here, we're going to lower our orbit. And we actually want to raise our orbit here because we want to escape the Saturn system to go home to Earth. So you want to escape Iapetus when you're going forward with Saturn, and you want to escape Saturn when you're going backwards with the Sun. I know that sounds really weird, but I think you'll understand what I mean when I explain it when we get closer. So we're going to have to go halfway around Saturn in order to be ready. So what I'm going to do is go back to HUD here, and this time we're not doing anything with sync orbit. Let's bring our second orbit up here, but this time we're going to put this one onto Saturn. And what we're going to do is we're going to eject when we get on the low side, the lower circle that's right there. Okay, so we are going to wait until that time now. Just sit going around and around Iapetus. And actually, I just realized that would not take much time at all, because all we're doing is we're going to go basically, we're in the exact wrong place. So we're just going to go halfway around Iapetus. And that's going to bring us to exactly where we need to be. Ooh, nice. Let's get another picture. All right, so we're halfway around, so Saturn should be, yep, it's exactly halfway out right now. So we're going to keep drifting around here. And now we're getting close. So you can see that we're getting in the direction of Saturn's velocity vector, and this is going to boost our orbit a little bit. Which, like I said, is the intention. So this is basically very similar to what we did at Earth. When we wanted to come to Saturn, we just basically went on the night side. It just so happens that Iapetus, being a moon, is also on the night side. But either way, let's see. Okay. It's time now, so if I go to Prograde and now show the HUD for Saturn, this should be lining up pretty well. So this is going to take us to the Iapetus velocity vector, and it should be very darn similar to the Saturn velocity vector. Okay, looks like we're about 12 degrees off, so that's close enough. So what I'm going to do is get my numbers now. So what we're going to do is get 29919 point. Looks like we're at 4, so we lost 1/10 of a kilogram going around. Our velocity is now 364. And what we're going to do is we're going to add 167 meters per second onto 364. And we're just going to burn that straight up value. So that brings us to 531. That's where we cut the engines. We don't know what our final mass is, but either way, we are going now. So let's quick save. Okay, turn prograde. And we're going to burn until we see 531 on OS. 3, 2, 1, eject. 400, 450, 500. Oh shoot. That came up a lot faster than I thought it would be, but we only overburned by 2 meters per second. So we'll put 533. Okay, final mass is going to be 29905.5. Let's see, that means we used 170. So yeah, we did overburn there, as expected. Although actually, I just realized I'm not copying the right line down here. So what I need to do is we need to get everything onto this second line here as is. So now what I do is I'm going to copy the line above for this one. Except here. And I'm going to use 29919.4 in both instances. Perfect. Okay, so there we go. We've got a 1-to-1 correlation. So we saved a lot on the ascent. We lost a few on the escape. That's okay. Because it's potential energy, we're going to end up benefiting from that in the end. So let's see, at this point, The only thing that's left to do is to prepare the numbers for the plane change alignment to Earth. Currently left in the tank is 1139.4 and mass of the ship 29905.5 kilograms, and we don't know what V1 is going to be yet. So let's just confirm 1139.4 versus 1101.4. So we're probably going to lose a little bit of margin here. We've got 38 kilograms of margin right now. So that's good. You can kind of see like where we screwed up here. We screwed up once, and then that was the ascent. That was out of my control. Then I decided that, well, first I decided that I was going to force a bad transfer to Iapetus. That was my fault, and that's where we came really close. So we skirted with some abort here, and then my landings on Iapetus were good, and then started to get me some breathing room again. So now you can see we're slowly getting off of that, and I'm going to try to get as much margin back as I can, getting back to Earth, because you can see there's a real precipice coming. We're going to get some really high energy burns very soon. Anyway, that's it for the time being. So now we quick save. And at this point, we're basically going to eject away from Iapetus, and once we get out of the gravitational influence of Iapetus, we'll know what our achieved orbit is. Gonna get a nice picture here. Always got to get your pictures. It's part of the trip. Literally, the next episode is taking a look at our calculations, taking a look at our pictures, and putting a bow on the whole thing. Very nice. So we've got Saturn, Iapetus, and us. Okay, so I think we've pretty much settled out now, so we're going to go back to Saturn. And the achieved orbit we got was 3586 to 3785. And I wanted 3561. So that's the periapsis to 3719. Or 3917. So we got a more circular orbit. I made a mistake. I should have burned, right, because your ejection angle is not straight out. It's I think it's 45 degrees for a perfect ejection. So that was, at least it wasn't bad, but it wasn't good. So I'm gonna write that down in the actionable items. Plan the Iapetus ejection burn better, because after the burn you will, what's the word here, swing about 45 degrees outward. Alright, so I've taken note of that. Alright, ladies and gentlemen, we are ready to plan our trip back to Earth. So, we're going to bring up the Transx right now. we're ready to escape. We're going to select set Earth. Whoops. There we go. And that's it. So now we can begin planning our trip. So, just make sure... Okay, good, it's working now. So let me show you how this burn works, okay? So if we went right now... The most efficient way to do this is to meet Earth when it's on the exact opposite side of the sun that we're on right now. So what the best place to be would be right here. But you can see that we're still at 185 Gs, right? And you can see that the Hohmann delta V is going to be on the order of 10,000. And look at what happens if I lower this here. Right, so we got down to 3 there. So if I tried to force it right now, without taking into account the time or date, we can take a look at what this burn would look like in terms of enclosing speed, and it's really bad. So let's see if we can try to get an encounter out of this. Just to prove my point. I don't want to spend too much time with it, but okay. That should be good enough for capture. Okay. We need 19 kilometers per second delta V to capture. I've only got room for oh yeah, and for circular you're going to need 19.6. I've only got 7.8. So you can see that we've got twice as much than what we were expecting. So what I'm going to have to do here is wait. You know, be like that sign on the crosswalk that's like, wait. We can't go just yet. So the solution is to leave that at 0, take our prograde velocity back to the most efficient location, which is right there, and then wait for the Earth to be in the right place. The way we do that is just increase the date, and I can see already we're going to be out here for another 9 months. Let's go to, yeah, rough. Yeah, things are getting real rough now. So you see, we're going to go around with the Earth, and then we should start to get close after, yes, the Earth goes around. So now we're down to 6. So basically what I'm going to do is I'm going to zero in on the lowest possible number that I can get. And then I get a reasonable ejection date and ejection burn. Then once we get that, we're going to plan the inclination adjustment that we need to do. We will make the inclination adjustment, and then we will be able to eject from the Saturn system. Okay, I've spent more or less an eternity on trying to get this thing nailed down, and it looks good. So if we go forward, you can see I've now got the altitude within 5,000 kilometers of the surface of Earth. I'm not going to bother getting it more accurate than that, because these predictions will change as we wait for our opportunity. Remember, it's going to end up being something like closer to 9 months until we're ready. So basically what I'm trying to say is it's no use doing overkill. This is close enough. So right now it's saying that the circular delta is 9.06, and Let's see, I budgeted 7.8. Let me try to get that. I'm going to try to get that down even more, as crazy as that sounds. Okay, so I've finally gotten it down as low as I can. So, unfortunately, it looks like we're going to be using more fuel than I budgeted for. Remember, this is what I said was the scary burn. But we actually have it planned so well now that the solution is almost unstable in real time, which is crazy considering that it takes us 30 years to go around the Earth. But that's how well I have it planned right now. So what I want to do at this point is save my variables that I have. Whoops, I don't want to hit forward, I want back. Alright, so we're going to do prograde, and then there's the ejection date, then there's outward, and then there's plane change. So let's see, prograde negative 5.633K, and for some reason Excel thinks that's a formula. Guess it's the minus sign. Alright, and then ejection date ultra. This is going to be important that I get all the digits here. 61614.1072. And then the outward velocity, negative 22.51. Again, you know, I said I'm not a fan of outward, so I managed to find a solution with very little outward velocity, just 22 meters per second. And then the plane change, negative 444. So that is our plan. The next thing I going to do is take down the capture delta. Actually, let's do periapsis velocity, circular delta. Actually, no, capture delta. And then circular delta. So PE velocity 16.66K. Let's see, capture delta 5.558K. That's the one that really matters. I can use aero braking if I have to get the other one down. So 8.811K. Okay, so basically what I'm trying to say is I budgeted 7.8 kilometers per second. Right now it's showing a bigger burn at 8.8 kilometers per second, so that's a 1.1 kilometer per second increase. If we start to get into a situation where we're running out of fuel, I can perform aero brakes to start to lower that apogee and bring us into a circular. That's why it tells you a capture as well as a circular. It's because if you want to do an aero capture, the number that really matters is 5.56. If you can't make 5.56 kilometers per second, bye-bye. No, that's not David Bowie. Never mind. So yeah, and then we've got an inclination of 82 degrees, which we probably we'll fix that up so we're not quite at 82 degrees. That's a little bit too high for my liking. I'd prefer to be closer to about 50 degrees. Remember, we have to do at least 38 degrees to hit Wallops Flight Facility. So I'm not going to accept anything less than 38 degrees. Okay, then the last thing that we need to do is go back to our initial escape plan here. And what we're going to do now is increase our periapsis distance to, let's see, we're over here. Let me see, I think I need to, yeah, there we go, change that to ecliptic. The ejection is going to be over on this side, so that's halfway between our radius. So we'll go to 3.637 G. Okay, that's close enough. So Alright, now it comes down to our relative inclination. It's actually only 13 degrees, which is not bad. Let's see if we can accept that as it is. So going over to our calculators here, I want to go down to delta V, and let's see what this is going to cost us. So our semi-major axis is 3.685 times 10 to the... Oh, that reminds me. I got the wrong number. I knew it didn't look right. 3.685 G is what we wanted. .685. Okay, fix that. So now for the semi-major axis, 3.685 times 10 to the 9th. Then we have the radius that we're going to be doing this burn at. Let's see, the radius is going to be, I guess I don't know that yet, but it's probably going to be close to my semi-major axis. So 3.685 times 10 to the 9th. The mass of Saturn, which is 5.68 times 10 to the 26? Yeah, 26. Relative inclination difference is 13.28. And we get a delta V requirement of 742 meters per second. And let's see how that compares with our prediction. That is within the prediction. So we're good. We're good there. But let's see if I can make this even better. So what we're going to do is mess around with the ejection orientation. And I have a note in my guide to use that as sort of like a special fuel saver. I'm going to see if we can. Normally I would say let's not, but we're running kind of low on margins, and that delta, that MCC train is not making me feel good. So let's see what we can do with this. So what I'm going to do is start messing with this, and we'll see how close we can get on our relative inclination here. 2.6. Not bad. That's next to nothing. And just make sure that this time to burn changes here. Actually, it doesn't. So what's changing? The velocity's not changing. Oh yeah, that's the other thing that I didn't check yet. Alright, so that's as low as we're going to get for ejection orientation. Let's just make sure that we're still, yes, we're still good. And the damage is 4.015 kilometers per second. Alright, this, we're going to take a little bit of a hit. So we're going to use less fuel for the plane change, but we're going to use more fuel on the Earth transfer injection. I budgeted 3858, and we're showing 4015. So now I'm going to come over here. We'll do align planes. And this was scaring me until I figured out that it was due to selecting Iapetus. Right now, I want to center on Saturn. And what we're going to do is target ELS for... Oh, Saturn to Earth looks pretty good too. That's showing the 11 degrees. But for our current ejection, I need a... What is it? The inclination? Yeah, and the land. 16.14 and 129.8. So we should see 2.6 degrees. Excellent. So now what we do is we're going to wait until our descending node comes up. And then once it does, we're going to burn in the descending direction. Wait a minute, descending node. No, sorry, we burn in the ascending direction, so we'll turn orbit normal plus. We'll run the engines for 2.6. And let's see, on the fuel budgeter. Actually, no, I wanted. I wanted the plane change delta V. There we go. So now our inclination difference is 2.61. That is showing a delta V of just 146 meters per second. So that's pretty damn fantastic. Alright, so we're pretty much ready to go. We're going to wait until the descending node, and once we start to get close, we're going to make that plane change. But first I have to get the numbers. So go ahead and quick save, and I will see you guys when we come up for that maneuver. Okay, we're about 5 minutes from go time now, so we're at the descending node. So we're going to turn normal plus, and we're expecting to run the engines for about 14 seconds. Once we settle out, I will retrieve the numbers. And then once this burn is done, the other thing that I forgot to get is our ejection date, figure out just exactly how far away it is from right now. I know it's a couple months away, and I wrote that number down, but I need to equate it to how many days it is from now. Alright, so we got 4 minutes to go. Good time to get the numbers. So, our delta V right now, V1 is 3132. So we want it to be 3132 at the end. Our current mass of fuel in the tank is 1139.4. Good. That shouldn't have changed. But what will change is our ship mass. So that's 29875.937. Well, I don't need that many digits. We're not that close. I'll do 0.9. And then I don't know what the other numbers are, so let's see. We should be good to go. Alright, we're ready to do our plane change, so it's going to take about 14 seconds. Alright, so I was a little bit wrong about the duration. The duration is going to be 7 seconds, but we're going to light up 3.5 seconds before the node. So we're about 40 seconds away now, so I'll go ahead and quick save, and we'll activate attitude control for normal plus, and we're standing by for the burn time. $20 seconds. $10 seconds. Three, 2, 1, now. Alright, 1.7, 1.1, 0.9, 0.7, 0.5, 0.3, 0.2, 0.1, and we're going to get this one exact, so we're probably going to see the nodes flip. Yep, they just did. Okay, that's it. Control off, and that's it. Alright, numbers coming out of the plane change burn. 3133, so we picked up 1 meter per second. That's okay. And the final mass of the ship is currently 29864.3. So we used 142 meters per second. And estimated masses next time 1127.8 and 29864.2. So let's see what we've got now in terms of margins. We've got 95 kilograms. That's good. So we're slowly building it back. You can see we're in a better position. Yeah, let me put it that way. We're in a better position there than we were coming out of Titan, coming up to this precipice. And remember, when we're out of this thing, if we still have the right amount of fuel, we're going to have like 130 kilograms left. It's going to be insanely low. We're going to be getting like fuel low warnings, and yeah, that's fine. I mean, that's expected. Okay, so oh right, we're going to equate the time to the ejection. So the ejection date was 61614. Okay, they just confirmed that. That's a really important number to get right. We missed that. We're up for another year. Now that's the closing date. I need, there it is, 61614.1. Today is 61262.26. Oh man. If I hadn't have waited in the Iapetus, we might have been able to go there. But we're literally going to be orbiting Saturn for an entire year. So I'm probably going to have to fix up the orbit. I might have to station keep, but I'm going to try to do that using my RCS so that I don't have to make it an actual maneuver. So, 350 days. What I want to do now, Iapetus takes a long time to orbit, but not 350 days. So now what I want to do is go to sync orbit, and I want to target Iapetus, and I want to see how close we come in. Let's see, what is 1 year in seconds? 365.25 times 86,400. It looks like 1 year is... I can't read that number. Divide by 1,000, please. 31.56 million seconds. 31.56 million seconds. Okay, so we've got an entire year of the Iapetus orbits here. Right now, it's showing the minimum time between us and Iapetus of being 389,400, which comes on the next orbit, and the difference grows. I think, yeah, the difference grows, and that was intentional. So let's see, 389,400 over the entire duration. Let me watch this close pass, and then we'll see how close it is, and if it's fine, we'll just keep going. So I'm going to fast forward to that location, and I'll let you guys know how close we come. Okay, so it's just happened. You can see we've now flipped over to the next orbit, which is 771. That makes sense. So that's going to be twice as much as this one, and then the orbit 2 will be twice as much, orbit 3 and 4. So it's we're gonna progressively get further distant to Iapetus. But yeah, for reference, I'm pointing the nose right at Iapetus. That's how close we are. So we have absolutely no concern. Let's see if I can get a picture real quick. Oh, yeah. Very nice with the rings and everything. The other thing that I can do is take a look at our orbit. So we've developed 0.01 degrees of relative inclination. That's next to nothing. And I also want to check our orbit, and that's at 3697. And let me take a look at our plane change that has my old semi-major axis in it. It used to be 3685. So that's changed by, looks like 1.2 thousand kilometers. Or 1.2 thousand. Or 12,000. That's next to nothing, though. So it looks like we will not need to station heat. So at this point, what we can do is put the craft into deep freeze, and we'll just sit here waiting for, it's like Monty Python, our orbit. Winter blossomed into spring, which went into summer, and then spring and summer, or what is it? Spring and summer gave winter a break, and it went straight on into autumn or something like that. And then one day, we'll wake the craft up and head back to Earth. So, we should have a power off cockpit, secure configuration. That's it. Tertiary HUD off. Secondary HUD off. Main HUD off. Radiator, check that it's open. It is. Nav beacon and strobe off. They are. RCS mode off.
Off.
Retro and hover doors are closed. Good. And the last thing we need to check is our O2. O2 is ticking, it's flowing, and we've got 4,793 days. I really wish it showed you years too, but I think when they designed the Raven Star, it was designed as like a moon shuttle, not a Saturn skyhopper. So anyhow, I calculate 13 years, and we're not even staying 1 year. It's going to be about 9 months from now. It was slightly longer than I thought. It was like 11 months from the beginning, which is the longest time that I can possibly wait. But like I said, I'm not going to accept the bad. I showed you guys using TransX. I cannot accept the bad timing. I will get so messed up we won't even be able to get into orbit around Earth. So, yeah. Okay, so at this point, we're going free drift, and we'll pick up when we're on the orbit. Let's say when we're one orbit to go from the ejection burn, and that will be our opportunity to firm up any difference in relative inclination, change the prograde, distance, that sort of thing. It gives us time to do all of that. So this is it. See you guys in about 9 months. Hey guys, so I just realized something. So with TransX, what it does is it tells you when the best time to burn is, but that doesn't necessarily mean that you're in the periapsis position when it's time to do that burn. Unfortunately, the orbit of Iapetus is so large that it takes 2 months to go around. And it just so turns out that when we're supposed to burn, we're supposed to be on the opposite side, meaning that we'd be a month late. And we can't afford that. So what I decided to do was add this new burn. I'm defining a new burn here called periapsis timing burn. I made a note down here to add it.
So how did I solve this? So I said, okay, what's my current semi-major axis? So I logged it here, and then I calculated using the orbital timing equation how many days is my orbit. So there's the answer. So then I said, okay, well, on the projection for transx for what my periapsis modified Julian date is, basically when I'm closest to the burn, it's going to be 61387, which happens to be 227 days from the intercepts. So if I try to split it into 3 orbits, I would have to kill velocity and slow down, which is pointless because I'm speeding up. So my next option is 2 orbits. So I said, okay, for 2 orbits in the remaining days, what is going to be my new period in seconds? So in other words, half of 227 days in seconds, so that we go around Saturn twice. And what I find is that we need a semi-major axis of 4.52 million kilometers. And then from that, I said, okay, well, here's my perigee right now. So then I took all of this information into the vis viva equation here and said, okay, we're orbiting Saturn, and the semi-major axis is going to start at 3.687 gigameters, and it's going to become 4.52 gigameters. So then I found 2 velocities, took the difference of the velocity, and that's how I arrived at this number. So then what I said is, okay, it's in the direction that I want to eject. So that's actually going to subtract the amount of delta V that I need. So now I took the anticipated delta V that I was expecting to use in the first place and subtracted 279 from it, because the timing burn will help perform an ejection. So the total expected fuel needed remains unchanged, and that keeps it so that this graph doesn't get messed up. So we are good to go. So now, when I realized that we were about 80 degrees from the periapsis ejection location, so now I'm going to actually wait for that to occur, and then we're going to perform this 279 meter per second burn. We'll get the numbers first, though. Well, actually, we need to go a little bit longer before we can get those, although I need to drag this formula up, and I need to copy these numbers up and delete those because we don't know what it is yet. Okay, so now we're ready to wait until we get closer.
Okay, so we've got about 2 minutes to go. Now we're going to delay the maneuver a little bit, which is fine because we're not burning the whole time. This is giving us the time if we wanted to perform the entire ejection burn, which we don't want to do. So it's only going to be a few seconds. But we need to run the maneuver checklist. So check throttles are off. They are. Hover and retro doors as desired. We do not need them. They'll stay closed. RCS mode rotation. Let's see. Lights as desired. Unnecessary. HUD on orbit. Then we want secondary HUD on. Tertiary HUD on. And actually I wanted 5 mode there. And it just so turns out that we're actually pretty close to where we're going to burn, which is handy. Now, it shouldn't matter from a standpoint of timing here, the exact amount of time to wait, because we're going to be okay regardless, because we're only doing half the burn. and this is a matter of months long, so when we get to the begin burn, we'll just go ahead and light the engines up. So we want to burn until our semi-major axis is at 4.52 gigameters. And it shouldn't require much velocity because we're really, really far out of Saturn right now. I mean, you can take a look. That's how far out we are. All right, 20 seconds to the burn. I'm going to get my final numbers here. 11, 27.8, no change is expected, and 29,750.8. Wait a minute, 29,750? Oh yeah, 29,750.8. We took a lot of oxygen there. I guess it makes sense, you know, we're carrying 6,000 kilograms worth of it. Okay, V1, 3279. And we are ready to go. Lighting the engines up in 3, 2, 1, now. Okay, there's 4, 4.1, 4.2, 4.3, 4.4, 4.51, 4.52. Alright, that's good enough. So we're going to quick save. And it's time to get our numbers for this timing burn. So V2, 3552. Current mass, 29,728.6. So that took 273 meters per second, a little bit less than I was expecting, so that's kind of nice. And then expected fuel before the next burn, 1105.6. Initial mass, 29,728.6. And V1 should be 3552. Should be. It's probably not going to be, but it should be about that value. Alright, so now we've got 2 orbits to do, which means we'll go around once, and we'll come back here, see if we need to make any further adjustments to this to ensure that we arrive here at the right time. Then we'll do a final inclination adjustment up here, then we'll eject. Okay, so we're back in position. Actually, you know what? Let's turn retro here. Because it shouldn't use up much fuel. So right now, what I'm looking at is this modified Julian date right here. And what I want is that for that value to update to, and I'm going to write this down, 61614.1. That's the value I want to see. And in about 40 seconds that should update. Yet at the same time, we should probably fix this a little bit here. because I see in the time since we had solved this, yeah, we've moved a little bit. So let's get this fixed up. Okay, that should be fine for the time of ejection. It's not going to make a big difference here. All right, so let's see. That's going to put us a little bit further along. And I'm also going to have to update the time here. Yeah, let me get something really accurate, and then we'll figure out what it is. All right, so I got us down to about 100, which is a matter of a meter per second or two. So it won't matter using the main engines after this. So the new ejection date is going to be 61614.5. And that's the number that I want to see come up right here in just about 10 seconds from now. Yeah, update. Alright, maybe we'll speed up a little bit and see if that flips over. It usually waits, I think, a little bit, and then it'll... There it goes, 61611.8. Okay, so what this means is we're showing up a little bit fast. So I'm going to activate retrograde, and we need to add velocity.
Translation.
So I'm going to translate backwards a little bit until this 61611.8 becomes 61614.5. That's using a little bit more than I thought it would take. This is about the limits of what I can do with translation. No, that's 3.5. One more. You can see I'm really babying this burn because it's a big deal. You get this thing wrong, you're not going to be able to come home. You're going to fly past the Earth at like 20 kilometers per second and be like, there's no way. That's what I'm trying to avoid. 61614.5. Okay, so now what I'm going to do is I'm going to flip around to the top side. I'm going to get our relative inclination fixed, and then I'm going to check on this time one more time, and that's our last chance to fix it. I want to adjust it on the periapsis side so that we take advantage of the Oberth effect. We don't want to raise this side of the orbit. We only want to raise this side, but I will have to some amount on the apoapsis side. So I'm going to need to take care of that. Ooh. That's kind of close. We're going to be pretty close to Iapetus. think it should be okay, but that's a little bit unfortunate. We're timed up. Hopefully we're going to pass under it. Let me see what our plane looks like with Iapetus. So the node is here, and the concern is where we are now, I think. So, yeah, we might be a little bit close. All right, I'm gonna keep an eye on the Iapetus. I'm getting worried that we're gonna get close enough to have a gravitational encounter here. That could mess us up. Sync orbit. All right, so I'm gonna quick save, and again, this is a translation burn. We're gonna come around to the top side of the orbit, and we're going to fix any remaining relative inclination and time deltas there. See you then. Okay, it's time. So we're going to go to select align planes, and we want an ELS of 16.14 and 129.8. So we're at an ascending node, which means we're going to burn descending. So we're still on translation. So I'm going to burn down until our relative inclination settles out at around 0. All right, that's it. That's all I can do.
Rotation.
Whoops.
Translation.
I did want translation for the second one. Our modified Julian date's now 0.25, so we're 6 hours off. Let's see, we're at 137 now, which is still acceptable. Again, that's a difference of that won't matter. That'll be something that we can fix, like we just fixed with the translation here, and like we're about to fix with this. So we want 614.5. So we're gonna go. Let's turn retrograde first. And again, I need to add energy to the orbit, so we're going to translate backwards because we're facing backwards. And we want this to say 61614.5. Cool, that's it. 0 relative inclination, 0 arrival difference. All we got to do is just make sure 100%. We're going to be at 3.643. 3.643. Right there. Okay, we are prepared for the ejection burn, for Earth transfer injection. So I'm going to quick save, and this is it. So I'm going to run the maneuver checklist when we get close here, because this is a very critical burn. Gotta get that right. We're going to use up like half of the fuel, maybe not half, but about a third of the fuel that we have left. So it's going to be a really big deal. And it gets us back heading out in towards
Rotation
the sun, towards Earth. So that's it. We have quite a ways to go. I'll check up on my oxygen here. We look good. Okay, I will see you guys when we are, we'll say, 5 minutes out from the burn. Well, let's do 6. Okay, we're about 6.5 minutes before the burn now. So we're going to run the maneuver checklist now. Check throttles off, throttles are off. Hover and retro doors as desired. We want them closed, they are closed. RCS mode rotation.
Rotation.
Lights as desired, all lights are off. HUD on. Orbit. Secondary HUD on. Mode 5, tertiary HUD is on. So we're ready to go. Let me just do a quick sanity check here. We'll turn prograde. Oh shoot, I also need to solve the burn vector. Let's see, so I think we've already taken care of the plane change velocity. We've also taken care of the... Have we taken care of the outward? I don't think we have. That's so small, though, that we'll basically run it off of the semi-major difference value right here, which is 2.49. This is the value that we're going to adjust. Let's see, and then that's the end of the checklist. Is there anything else I was going to do? So I wanted to solve the maneuver. Can't think of it for the time being, so let's go ahead and get the numbers. So main fuel, we have 1105.6. The mass of the ship is 29,514.2. Then the V1 is 3551. 1 meter per second off. Not bad. I knew that was going to be different, but I didn't think it would be that similar. Very nice. And then that's it. So this is going to be approximately a 3.5 kilometer per second burn. It's going to last about, I think, between 3.5 and 4 minutes. It's going to take about 500 kilograms. Wait, no, that's not right. 250. So when we're done, we're probably going to be left with like 850 left in the tank. And just to confirm, let's make sure that we have good margins. We do. We have 93 kilograms worth of margin. We're now 3.5 minutes from the burn. So I think I am set up here. Again, we're going to introduce any outward velocity using the semi-major difference. Oh yeah, I want to do a sanity check. Okay, so the way I'm going to do that is I'm looking at the sun, right? That's the sun. If I look up, I should see the North Pole. Okay, good. So that means all of the planets are going to pass in front of the sun left to right, and they're going to turn around and pass behind the sun right to left. So what this means is we should be sun anti-velocity. Yep, there is Saturn, the last good image that we're going to get of it, and its beautiful moons before we head outwards. Keep an eye on we got 2.5 minutes to go now. So if I go to orbit reference sun and do HUD, yes, we are pretty much retrograde of the sun, and we're going to have a little bit of a hyperbolic swing. So this is what I was talking about that I failed to take into account when we left Iapetus. I went out there and swung left of that. What I needed to do was do it a little bit before and swing into it. So that's where I screwed up. Okay, auto-reference Saturn and HUD back to Saturn. We're prograde, we're in the right direction. There's 2 minutes until the beginning of the burn. We have about 110 seconds times 2, or 220 seconds, 3 minute and 40 second burn. We're in rotation. Going to use yaw as necessary to eliminate semi-major difference. And this is it. So we're pretty much going to do the most consequential burn, not the most important. That's the last. That's the one where we get into orbit around the Earth, but it's the most consequential burn. If we don't get this right and we can't solve it using the fuel that we have on board, we're not going to make it back. Okay, we have 70 seconds until the start of the burn. Since this is a long burn, I'm going to start at 2 and end at -2. Let's see, anything else that I need to check? I don't think so. Let's just make sure our relative inclination is good, and the current modified Julian date is, we're a little bit off, 61614.0, and this is saying 0.54. I don't know. Hopefully things will be okay. Okay, 30 seconds to the burn ramp. -20. All right, -10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, -1, -2. All right, here we go. We are leaving the Saturn system now. Here we go. Eccentricity is 0.96, and boom, we have escaped Saturn. Let's take a look. Here comes our solution. Looks good so far. We're about halfway into the burn. Still doing good on fuel. Yep, we're about halfway into our expected fuel burn here. Still looks good. See, our semi-major difference is coming down. That's good. Okay, we're more than halfway through the burn now. Everything still looks good. Of the way through the burn, still looks good. All right, 900 meters per second to go. Solution still looks nominal. I'd call that nominal, not just good, that's nominal. 600 meters per second to go. I know you guys can read this. This is so I don't get distracted. I'm talking to myself here. 300. All right, last look. Everything still looks good. That's nominal. All right, here we go. 100, 83, 20, 30, 20. All right, slowing, and this is it. 2, 1.5, 1. Cut off.
Translation. Rotation. Translation.
I think we're good. With whatever little difference is there, we're going to have to fix in the mid-course corrections. So that tells me the next thing. So let's take a look at the sun. It might not show right. Okay, it's showing right. So this is our current position. The left side is going to be Earth. So we're going to wait until we reach about where this square is. So we want to be a good 30 degrees off of where Saturn is before I start to do my burns. That's because I've noticed that with Titan, when we started pulling away from the large gravitational source and entering the other main gravitational source, our calculations and predicts were getting messed up, and they stabilized when we were, a good distance away from the object. So I think that's what we need to do, is no matter how far it gets off, we're just going to have to suck it up until it stops moving. And then once that magical third force, which is what it was probably Uranus last time, this time it's going to be Saturn. Once that magical force stops, then we can start looking into a mid-course correction. Okay, I'm officially calling the end of the ejection burn. We're going to quick save at this point. It looks good graphically. Both graphically here and numerically here, things look really good. So our V2, I should have gotten that earlier, 7264. Our current vessel mass, 29,216.2. That took 3,716-ish meters per second. Yeah, we knew it was going to take more, so that's a little bit unfortunate. Alright, so our current fuel mass, 807.9 kilograms. We're out of the thousands. But I guess it's fitting because we're coming back to Earth now. And our predicted mass for the next maneuver, 29,216 point, we'll round down. It's going to be way less than that. V1 is going to be something wildly high, like maybe 7 kilometers per second, something like that. And now I want to figure out how much margin I have. So there's 808 left in the tank. We need 740. So yeah, we lost a little bit of margin here. We've got 67 kilograms of margin left. So I'm going to save this. And you can see we've fallen, but we've kept pace. So that's kind of what I like to see. So then there's the shelf for the mid-course corrections, and then this big final drop-off is getting into Earth orbit. Once we've hit that, we're rescuable. Even if we run out of fuel, we can dispatch an emergency rescue ship, and it will get to us in time. So we're good. And now we will be shutting down. So we're going into our secure configuration checklist here. We're going to execute everything. Tertiary HUD off. Secondary HUD off. Main HUD off. Radiator confirm open. It is open. I'm going to check the coolant temperature. We're 31.2 and stable. Nav, beacon, and strobe off. RCS mode off.
Rotation off.
Hover and retro doors check closed, and I'll check the airlock. Everything is closed, pressurized. Nose cone is closed as well. Check O2. We have 4,488 days remaining. 4488 divided by 365 days in a year, we get 12 years of fuel at this, or 12 years of oxygen rather. And at this point, we anticipate oh man, that's not it. It's not in years. Where did I put this thing? Ah, there we go. the Iapetus to Earth phase. It's going to take 61,000 hours. 2,560 days. So we're going to use just over half of our oxygen on the way back. Absolutely no concerns. Okay, we're all secure. We'll leave that open. Let's get this back onto Saturn. And to be honest, we really don't even need it. So I'm going to power that down. And quick save. Alright folks, this begins our long cruise phase back to Earth. Actually, I forgot real quick, we gotta keep an eye on Iapetus. We're actually pretty close to it right now. A lot closer than I would prefer. Oh yes, we're going to have a little bit of a flyby here. Okay. So it can't go straight up into crazy. Still 0.98. Alright, I really hope that doesn't mess up my my orbit here. Okay, we're gravitationally affected now. We're at 0.97. So Iapetus is going to do something to our orbit, but it should be something small. It is kind of nice though to, you know, have like a final flyby, kind of like the goodbye kiss from Saturn. We'll get one more picture here. All right, 0.96 for gravity now. Okay. And that's our flyby. So shouldn't do much damage, but it's gonna affect us at some point. Since we passed over the North Pole, it's probably going to be a planar alignment that's going to mess us up. All right, once Iapetus regresses to become a dot, we're going to go full time acceleration here. And that's it for Saturn. All right, we're now in the solar region. So I'm going to update the HUD to Sun. That's Saturn right there. That tiny little dot with cup handles. Alright guys, so we finally got our first predictions for Earth, and it's not looking good, unfortunately. We're showing 12 Gs, 12 gigameters for the closing distance, so I'm gonna need to solve this, and we're gonna do one mid-course correction maneuver here, just to make sure that we're on it, and then we'll stop until we get closer, because that's actually pretty distant. That's about almost 1/10 of an AU, so we're gonna need to fix that. But in the meantime, we need to get our numbers. So let's see, our fuel now is 807.9, and our current mass 28,995.9. V1 is 5711. Oh, check it out. The sun is right there. Oh, wait, no, that's Saturn. I keep making that mistake. Alright, so I'm going to turn maneuver mode on and solve this thing. So I'll do this off camera because it's probably going to take a long time. Unless it's one value. Oh, you know what? Maybe Iapetus screwed us up. Let me try adjusting plane change first. Okay, so it's not plane change. Alright, I'll fix this, and then come back. Okay, we've got a really good burn solution right now. It gets us to basically below the geosynchronous satellite system, 28,000 kilometers, which is fine for just an initial thing. Like I said, we're going to be way off with this crazy train of stuff. Alright, I need the maneuver checklist. Check throttles off. Throttles are off. Hover and retro doors as desired. They're closed. RCS mode rotation.
Rotation.
Lights as desired. They do not need to be on. Then we need the HUD on. The secondary HUD on. The tertiary HUD on. So we should be good to go. So we'll go ahead and, at this point, yes, no time acceleration, get up to our burn attitude here. And we're expecting about 173 meters per second for delta V here. And this is going to be a little bit challenging here because the way the system works is based off of mass, and my oxygen mass will change. So I'm going to need to pull more information here. We're in the burn attitude. Here we go. Here is mid-course correction 1. Alright, that's it. Let's go ahead and turn this off. And it's good enough. Alright, so final velocity, 5664. Hey, we slowed down. That's a good thing. Because that means we're going to... doesn't mean we're going to burn more as we get into Earth orbit. Let's see what we're at now. Okay, that's a little bit higher than we were at, but not by much. And it's also going to be, it's way higher because we are way higher. If we're lower, then this value is going to be lower. Again, that's the O-worth effect for you. All right, final mass is going to be 28,982.1. So what I'm going to need to do is every time I do a mid-course correction maneuver, I'm going to have to copy the final mass line out and keep track of that. So it's going to be a little bit challenging. All right, currently in the tank 794.2, and anticipated mass at the next burn 28,982. Okay, so with the numbers plugged in here, following the mid-course correction maneuver, you can see we're, like I said, keeping up with the plateau here, and we're going to have our next big drop. But of course, we're not finished the mid-course correction maneuvers. There's going to need to be more. Alright, I'm going to start shutting everything down again. So tertiary HUD off, secondary HUD off, primary HUD off. Radiator open, yes. Nav beacon strobe off, RCS mode off.
Off.
Hover and retro doors are closed. They are at check mode 2. We have 4,250 days remaining. It's moving, and we still got 4 people on board, which is really good. So that is it. The next mid-course correction maneuver that I'm going to make is going to be after this block. Because up until that point, we're too close to Saturn. You see Saturn's still contributing 4% of gravity. So we cannot assume that our numbers are 100% accurate. So we're gonna have to just, like I said, suck it up for the time being until we know that we're good. So, all right, I'll see you guys when we get further along. Hopefully it'll be even further than where we are now, but I have a feeling that we're probably going to need a big burn, another probably 200 meter per second burn as soon as we hit that that area, that node, which is what I'm using as the next opportunity. Yay! Big numbers far away from the Earth. Okay, it's Boreal Summer 2030. In fact, it's the 4th of July. Let's see if I can see any bright lights. Figured I'd be able to see Earth by now, but I guess not. Especially with all those fireworks going off. Alright, so as expected, we're way off again. So, the good news is we're further away from Saturn. Haven't quite stabilized yet, but it's getting to the point where we're going to have to fix it regardless, because it's gonna use thousands of meters per second if we don't attack this now. So, I think what I'm probably going to have to do is slow down again. Yep, that's exactly it. Alright, so let's get this. Oh man, that's a lot. Alright, I'm gonna continue solving this. I don't like where these numbers are going. They're in the high hundreds. That's gonna exceed my delta V allowance. Alright, got it fixed up. So we need new numbers. 794.2, 28, 209.3, and V1 is going to be whoa, I've never heard of that before. What is that, one of Jupiter's moons? Or Iapetus? That's interesting. Maybe that's going to be my next destination. Actually, it should be able to tell me. Well, maybe not. These numbers are rolling over. Whatever it is, it's a very, very, very fast object. Relative to us. Doesn't necessarily mean that it's going crazy. All right. So V1. Oh, that's right. We need this one. 8,055. So we're now orbiting the sun faster than we typically orbit Earth. All right, we're at the normal rate. Let's do our maneuver checklist. Check throttles off. Throttles are off. Hover and retro doors are closed. RCS mode rotation.
Rotation.
Lights as desired, all off. HUD on. Secondary HUD on. Tertiary HUD on. And we're ready to roll. All right, ready to roll.
Translation. Rotation.
Okay, we're back where we need to be. So now V2 is going to be 8,061. So hardly any of that was actually forward velocity. Most of it was plane change. Final mass 28,186.3. So now what I need to do is update. I need to calculate a proxy mass here. So what I need to do is figure out the difference between the final here minus, let's see, this one minus that one. All right, so that means our proxy mass is 28,959.1. So if I'm right, this should add to, I should have written that down. TransX said, I think it was like 297. So, right, if I put this number in here, it should give us that value. So if I put in 28,959.1, this number should read about 574. Maybe it was less. See, it's G over J, so it's just simply the initial mass and the final mass. So I need to figure out the delta between these two guys. And then subtract that from the above mass final, and that will give us our proxy mass. Whoa. Other way around. 28,959.1. Okay, so, alright, I'm doing it right. So right now that puts us at 465. So we've used a little bit more than half of our delta V for mid-course corrections. I'm going to hold my breath on this one because, like I said, last time there were 8. All right, secure configuration checklist. Tertiary, secondary, primary HUDs off, radiator open, nav beacon and strobe off, RCS mode off,
Off.
retro and hover doors closed, O2 is good. All right, that's it. Let's see how long we can survive again before we have to fix this yet again. All right, speed run. Next MCC. Throttles off, retro hover doors closed, RCS mode rotation. Lights as desired, all off. HUD on, secondary HUD on, tertiary HUD on. All right, ready to go. Plugging in my numbers here. I should have solved it off screen. Because I'll have to pause again. All right, fuel before the burn, 771.4. Initial mass of the ship, 27,842.9. V1 is now, we're now more than 10 kilometers per second. So that's not going to display the right velocity that I need. See if I do surface and OS. Nah, that's not going to tell me. Okay, then in that case we'll have to round 11,390, and we get a V2 and a final mass. Then we'll do the same thing with the proxy mass. Alright, I'm going to solve the orbit. Alright, we got a bullseye with 33.5 meters per second, which is not bad. That's a little bit better than what I was expecting to see here. All right, here we go, lighting up. Still a bullseye. All right, so now we get the new proxy mass, so still 11,390 for V2. And then our final mass is going to be 27,840.3. Alright, so to get a new proxy mass, what I'm going to do is I'm going to subtract the amount of fuel that took. So that's going to be initial minus final. And then I have to subtract that sum from the original proxy mass. So that gives us a new proxy mass of 28,956.5. 28,956.5. So we should go up by about 33. Yeah, perfect. Okay. I think that was exactly 33. Okay, so I definitely have the right equation. So that's good. We still got we got 768 left in the tank, and we need 666 when we get down to Earth. I suppose that's a fitting number for Earth, given how many problems there are there. I'm just kidding. Okay. That's it for the numbers. And we've disabled, so we're going to shut down again. Tertiary HUD off, secondary HUD off, radiator open, nav beacon strobe off, RCS mode off.
Off.
Hover and retro doors are closed, and O2 still looks good. Still got more than 3,000 days of oxygen left, and we should be most of the way through our trip home. We're almost halfway, which means we're almost 3/4 of the way home, because when you're since it's equal areas, equal time, when you're halfway down, it's to the 2/3 power. 2/3. What is 1/2 to the 2/3? I can do a lot of mental math in my head, but I can't do a 1/2 to the 2/3 power. And it's 0.62, so okay, it's not quite as much. We're probably about halfway through the journey now. But either way, we're getting into the inner solar system, which means the sun dominates instead of all these gas giants throwing us off. All right, I think we should be getting a little bit better. I'm hoping that we've only got 1 or 2 more MCCs left. So we did 3 so far, so maybe we can go for 5. Let's see, quick save, and I will see you guys when it's time to do this again. Let's find... Sun's looking a little bit bigger. Still cannot see the Earth yet, surprisingly enough. Let's see if we can find Saturn. Saturn should look about as small as Jupiter. Yeah, that's Saturn right there. You can also see Uranus, and see if we can see Neptune. You usually have to go far out from the inner solar system to see Neptune. I cannot see Neptune right now. Okay, so we're not far enough out. Alright, catch you on the flip side. Alright guys, good news.
Rotation.
So what would have been mid-course correction 4 is being waived. We should, at 7 meters per second, we should be able to roll with a translation burn here. It's going to be a long one, but I think we can do it. And if we can do it with RCS, we don't have to bookkeep it, which means it's going to be a lot quicker. All right, translation.
Translation.
And here we go. 1, 2, 3, 4. So it's going to be 4 times 7. It's going to be a 30-second translation maneuver. Not bad. Yeah, that wasn't bad at all. Alright, I think we're in pretty good shape, guys. This is pretty good. So now we're going to enter into the second phase of approach, which is we're so low that we have to specifically change our orbit so that we don't smash into the surface. I don't think we're there yet, but I think we're getting there. And the fact that I could waive that mid-course correction burn was very good. Very good sign. So let's see. We're showing 8.3 kilometers per second. Hey, that's actually lower than it was before. I was planning 7.8. So that's not bad at all. I'll take that. Alright, so we're going to quick save, and I think I just turned on the HUD and
Rotation off.
rotation. So we'll go ahead and sit here, and hopefully we'll be able to get closer to the inner solar system. And there is Venus and Earth. Okay, so we are starting to get close. Alright, fixing it again. This time we're about 100 megameters off, which, by the way, is 1/3 of the distance to the moon. So instead of trying to get into the Earth's gravitational sphere of influence, I'm starting to target
Translation.
my anticipated orbit, which is 6618. And if I subtract 6378 from that, that is, whoops, not enough zeros, 240 kilometers. So that's what I'm starting to go towards. So this is only 3 meters per second. Alright, we're really close to me feeling confident that we won't have any mid-course correction maneuvers from here on out. I think we're almost done with the main engines. Alright, so next time I'm going to fix it when this creeps up to 50, or we reach 21 kilometers per second, whichever happens first.
Rotation off.
Okay, at this point, I am confident to say we're definitely done with the main engines until we get into Earth orbit. So we're now at, let's see, 1.18.
Translation.
Alright, want to see how close I am to actually hitting Earth? That's how close. I'm gonna go take a trip through the outer core. That's how close I am.
Rotation.
Alright, so next correction we'll do at, let's see, we're at the point now where the velocity is gonna almost hedge off. So we're at 430 or 3 AUs. Let's do it when we're at 2 AUs. So when we get down to 300, when I say 300, or maybe I'll say 30 M. Okay, one more fix. This one is the same value, 1 meter per second. As you can see, there's no growing trend, so we don't have to worry about that at all. And the target area now
Translation.
is so small for these. I waited until my orbit was up to the geosynchronous satellites. So we're starting to target low, not just Earth orbit, but low Earth orbit. And we'll get closer and closer and closer until I finally say, okay, we're targeting 240. We're not quite there, but we're almost there. Turn that off. And we're in the mantle. That's good enough. So we're at just under 2 AU now. Let's see. Let me turn everything off so I don't mess anything up. Let's see, the sun. Oh, yeah. Pretty bright. Let's see. We can see Mercury now, and Mars. We're going to get close to Mars. Have to keep an eye on that. And you can see the moon now with Earth. That's pretty cool. Alright, so now I'm going to do target. Actually, you know what? Let's do the sync again. So we're going to do sync orbit, target Mars. Now this, unfortunately, with sync orbit, you can't tell it to theoretically use another value. So Let's see. We're here. Mars is there. Nope, we'll be safe. We are heading towards it, but we're going to sail right past it. I'm not even going to pay attention to this. Mars is so small that unless you're coming within 100,000 kilometers of it, it's not going to perturb your orbit. Alright, next check up. So we're at 304. So now let's say we did 30. So let's do 15,000 kilometers off, or 200 gigameters. I think we're that solid at this point. So 200 gigameters in altitude, or a approach greater than 15,000 kilometers. Okay, so here we are, and we've got an altitude forecast of 454 kilometers. And although it's not an equatorial inclination, our ecliptic inclination is at 38 degrees. So, I'm going to wave. So at this point, let's see, we should be able to get a reasonable distance estimate from Earth. Nope, it only has 5 digits. That's really annoying. We could pull Earth in this way. So we're at 64 gigameters. So I can reassess at 32. That's what I'm going to do, is reassess when I get to 32. Here's where we are in the grand scheme of things. We're getting really close. I think we're closer to the Sun than Mars right now. This can be the side. Let's see, Earth should, yeah, we're going to be there really quick. Okay, we're at 32 million kilometers from Earth now. So Earth is actually 2 pixels wide now. Actually, it looks like it's 4. Yeah, Earth is 4 pixels wide, the Moon is 2 pixels wide. So at this point, we are close enough that I can start doing quasi-Earth movements using
rotation,
the Earth orbit information instead of using trans-X. So we look good right now. We've got an inclination of 46 degrees. We're supposed to land. We do want to get that up higher. So what I'm going to do is I'm going to burn outward to raise the orbit up to, let's see, what should I do? 240 kilometers.
translation,
So it should be really quick.
rotation, translation,
Whoops. Alright, I need to slow down. That's good enough. 235, 42 degrees. We'll call it there. Alright, so now, I think we're good. For the encounter, I guess I do want to consider, let's see, we're off by, I'll say if I'm off by 1 Earth radius from the surface, I'll come back and look at it. Otherwise, we're going to wait for the encounter stage to happen, because we're in really good shape now. So I will see you guys when either of those happen. Okay, that happened a lot faster than I expected. We're at 20 Gs now, so we're what is that? 1/3 closer, but we're off again. So this time I need to burn opposite of this direction. We just basically spun in a circle at this point. So we're going to bring it back down to 240. Oh, and I forgot. We're in the sun's area, which means we should be using a green HUD now. I've been turning on and off so many times I didn't even think about it. But yeah, so my role with the HUDs is when I'm in a yellow system like Saturn or close enough Jupiter, I use a blue MFD, and I think the same is true with Mars. When I'm in space or an airless world like the Moon, I use green. And when I say in space, what I should say is in interplanetary space or Earth orbit. Alright, our inclination is getting too high.
Rotation. Translation.
Alright, I'll leave it there. It's probably going to change again, so I'm not going to overdo it. So this time I'll do 10 or encounter. Let's see if we can find Earth now. Oh yeah, there it is. Looks like both Earth and Moon are 4 pixels wide. We're getting close. Okay, we are guaranteed encounter now. The orbit has been inside the Earth pretty much this entire time. And we've got so close to the Earth that I've had to decelerate to 10,000 times acceleration. We're at 4 gigameters away now. Which means it's time to save. Because Earth and a lot of other planets with atmospheres, when they render, they can sometimes crash your event. Oh, yep, the Earth is solid now. Alright, we should get an encounter any second now. 0.98. Let's see, where is it? There it is. Oh yeah, it's really big. I'm surprised that the sun is still 0.97. We are 1.5. Okay, so we're at L2 right now. Well, we're approaching from a different direction, but we're about as far out as L1 and L2. Alright, I want to
Rotation.
fix up the orbit again. Because right now we're showing a retrograde approach. We want a prograde approach. For the Earth it matters. Not only does it rotate very quickly, but it's got thick atmosphere, and we definitely don't want to be going the other way. That increases the heat load.
Translation.
Alright, let's see. So, our inclination is too high, so I think we burn inwards. Yeah.
Rotation. Translation.
Looks like I waited a little bit too long here. Looks like translation is no longer able to fix our orbit. So, you take a look at the equatorial frame right now. We're showing an inclination of about 103 degrees. Let's see if I can increase the altitude here. Actually, we should be... Yeah, we're heading right for Earth. Let's see, the sun is, I think, behind us. Somewhere back there. We're heading for the sunlit side of Earth. Pretty darn close to 90 degrees up, so... Alright, let me try one more time.
Rotation.
I might be able to solve this visually. If it doesn't work, we're going to have to use the main engines in a mid-course correction maneuver, as much as I hate to do that, because if we had just paid attention earlier and burned a little bit earlier, we wouldn't be facing this problem. But I was a little bit too overconfident in being too close, and forgot that I was really aiming for 240 kilometers, not Earth center. And that's typically how it goes. As
Translation.
Alright, let's try this. See where the Earth's North Pole is. So that's the South Pole. So north is pretty close to the direction we're heading here. So the north-south line is there. Yeah, we need to go that way.
Rotation. Translation.
Alright, this one's going to have to be another mid-course correction maneuver, unfortunately. So I'm going to solve the orbit here, and we'll see what it takes. Okay, so I've got a solution now. It's a little bit bigger than what I was hoping. You know, if we did this earlier, it could have easily been next to nothing. But that's the way it goes. I really should standardize that approach procedure. I don't have any sort of rule, it's just sort of generic, so maybe that's just for next time. So I need to get these numbers. So 768.8 for fuel before. Initial mass, we're now down to 27,226.2. Let's see, V1. We really should be using the sun for this. Exactly 40 kilometers per second. And then V2 and mass final, we don't know what those are yet. So I'm going to have to update that one more time.
Rotation.
But anyway, time for us to maneuver here. I think three MCCs would have been amazing. This will be 4 though. That's not bad. I was honestly expecting 8, and then later expecting 5. So to end up with 4, that's really good. All right, lighting up. Okay, that's it. Now I do want to trim using translation. So. Let's see, V2, no change, still 40,000. Final mass is now 27,220.6. Alright, so I'm going to do the same thing, except this time I think I can drag the formula down because it's the same thing. What is it? Transx said 73. Alright, so we have a new proxy mass, 2,800, or 28,950.9. So we should go up to 570-ish? Yeah, 568. Still quite a bit less than our allotted amount of 800, over 800, so that's nice. And I'm really confident that we can do this. So let's put in the fuel levels, and we're going to get a low fuel warning once we do the Earth arrival burn. 763.4, and going to be a little bit lower than 27,220.6. And V1 will probably be somewhere around 14 kilometers per second. That'll be with the Earth. So I think we're done with our MCC block table. So let's bring this one home, shall we? Oh wait, no, we have to
Translation.
we have to trim here. So we're low. I want to go higher. Let's see, where's the Earth? So I'm not just screwing around pressing random buttons. Okay. So the Earth is, so we're basically in an Earth, we're still in an Earth orbital position. So we should burn outward against, or outward normal. That would take us away from Earth. Let's see what our equatorial inclination is here for Earth now. 56, that's fine. Right, get back to Sun.
Rotation off.
Alright, we're going to shut down for one more time. This should be it. Just a quick save. Okay, we have the encounter phase. So I will once again
rotation, translation,
shape this up. So let's see, we're a little bit high now. We need to decrease our altitude. Alright, that's it. We're heading in a positive direction, so
Rotation
6
off.
kilometers less is not a problem. Quick save, and hopefully we'll be able to go almost all the way to the encounter now. Alright, I can visually confirm that our inclination is good, because I recognize Africa now. We're coming in. We're stabilized at 235, so I will adjust one more time. Alright, there's 240. So we're coming in for Earth. And this time we are good to switch over to Earth, and we'll load the HUD up. We're almost fully Earthbound now. We can also turn prograde Earth. And we're getting really close to a firm number here, which is 8342 meters per second. So what I want to do at this point is figure out how much we've got left in the tank. And that should be an easy calculation. So coming over to my calculators. So remember, we had a safety margin of 5%. So we're showing that with 666 left in the tank. Actually, we got more than 740, so we can use this line. With more than 740 left in the tank, that means that we can do all of this times 1.05. So that's 10.07 kilometers, no, 10.7 kilometers per second. And we need 8.3. So guys, it looks really good for coming home. We make this burn, we are home free. We can be rescued at any point. Now, this transX will not count down for the burn, so that is something that I'm going to have to do, and this is where this maneuver timing gets extremely important. When you're having these massive burns, where the timing matters, like if we don't burn at the right time, it's bye-bye. Like so what if you burn 8 kilometers per second? If you didn't burn at the right time, it's bye-bye forever. Alright, so 8342. Ship initial mass is, what are we at now? We're at 27,216.8. 27,216.8. Let's see, tank capacity, that doesn't change, ISP doesn't change, engine force doesn't change. Okay. So this is going to be a 375 second burn, or 6 minutes 15 seconds, which means we begin the burn 187.5 seconds from periapsis. And can we confirm? Yes, it's still 240 kilometers. So here we go, coming in over the Pacific now. We're somewhere over probably Guam. If I had to take it, oh boy, that's way too much. Way too much frame rate drop there. So home, but we're not quite there. We got to make this burn. Let's see, we are about 2 minutes from apogee at this current speed, and we'll come back in. I need to wake the ship up. This is a very important burn, so I'm gonna start it a full 6 minutes before periapsis. Okay, so one final check. It's almost too late to do it at this point, but 240 kilometers and a equatorial inclination of 58 degrees. So we are in an acceptable orbit to land at Wallops Flight Facility, or rather, we are coming into a acceptable orbit. We're moving at over 14 kilometers per second, which is insanely fast. We're moving at twice Earth's orbital velocity. And this is exactly what I was talking about for how consequential the last burn was. It could have been, I mean, you guys saw it was like, what, 20, 40 kilometers per second? It was insane. So, thank goodness we have succeeded on that most consequential burn. And now we have to do the most critical burn of all, the burn that stops us from flying off into infinity. We're in a good position to do it right now. All right, okay, let's see. We are 7 minutes from... All right, 390, 80, 70, and right there, 6 minutes from. Okay, this burn will be done retrograde, so we're going to turn retrograde. And time to wake up the ship for maneuver. Okay, maneuver. Check throttles off. The throttles are off. Hover and retro thruster doors as desired. We will need neither, so both are closed. RCS mode rotation, already been done. Lights as desired. We are entering a habited planet's low orbit, so let's turn our strobe light on. HUD is on, secondary HUD on, tertiary HUD on. We should be good to go. This will be an 8,343 second burn. I'm going to confirm that I set 8342. It shouldn't make a difference though. Okay, we start, the burn will be 375 seconds in duration. That's 6 minutes 15 seconds. We're going to start the burn 188 seconds from periapsis transit. We're going to also do the 4-second ramp, and I'm going to try to not mess it up like I did last time. Not that it mattered that much, but it looks better. Okay, and now we can get the numbers coming into this burn. We have finally finished with the mid-course correction maneuvers. We finished with 569 of 812 meters per second. That's good. So, now I need to put the actual amount that's in the tank, 763.4, that's still correct, and the current mass, which is 27,216.4 kilograms. And it's still too early for V1, but it's going to be upwards of 15,690. God, that's fast. For Earth, that's really fast. This burn scares the living daylights out. Oh shoot! No, it's not 6. Oh boy, I almost screwed up. It's not 6 seconds from or 6 minutes from periapsis. It's 6 minutes from the start of the burn, which is 180 seconds from periapsis, which means we're 30 seconds out. All right, quick, confirm. 15,790, and we're going up with every passing second. We're about 30 seconds out. 763.4 confirmed. 27,216.4 confirmed. I think we're good to go. And I just missed it. It shouldn't impact us that much. Missing it by about 2 seconds. But yeah, that could have been done a little bit better. Let's keep an eye on the periapsis distance too. We want that to stay around 240.
Warning, main fuel low.
Yeah, figures. Okay, we acknowledge that the main fuel is low. We're taking a look. We needed 666. We've got more than... We just went under that amount of fuel. We're good to go. Acknowledge master warning.
System reset.
We're proceeding with the knowledge that we have less fuel than the cutoff here for the warning. Okay, I got a V1 of 15,790. Our circular delta was 8342. We're now a quarter of the way through the burn. Sure that we have more than 375 in the tank by the time we reach the halfway point. If not, we're going to have to do a cross feed, and I'm not expecting to do a cross feed because we still have margin, and as long as we still have margin, stay above that red line that I was talking about, then we shouldn't have to worry about cross feeding. So the ship is so light that when we started at the beginning, I think we were taking about accelerating at 1 G. We're now accelerating at like 2.2 Gs because we're so light. We're almost empty, and it's definitely time to come home. Okay, we're halfway through the burn. We've got 440. We started with 763, which means we burned 5, 6, 7, 40. We burned 340 kilograms, and we've got 420 left in the tank. So there's no concern. We've got 400 meters per second before our capture, and I don't remember quick saving, so let me go ahead and do that now. And here we go. 150, and here comes the critical point, right here, Earth capture. We're home, we're staying home. Okay guys, consider that the climax. No matter what happens now, we can be rescued. But I'm not planning on giving up. We are 3/4 of the way through the burn. Now 7/8 of the way through the burn, less than 1 kilometer per second to go. $700 to go. $500 to go. 300 to go. 200 to go. Let's see, not quite yet. Let's turn retrograde here. Alright, so I think, believe it or not, the 2.5 seconds of timing made a difference. We're not quite in a circular orbit right now. So we can try an apsid line rotation. D2 is going to be 7711. I can write that down now, because that shouldn't change. 7711. There we go. We're a little bit higher than I wanted to be, but that's good enough for a circular orbit. That's it. So, getting our final numbers. 7711 is already in the table. We're now at 26,581.1. So we used 8650, so that would have been 8350 plus about 300 outward. Left in the tank, 128.3. This means we lost a little bit of margin in doing that maneuver. We have 14 kilograms of margin left. Anticipated mass before re-entry, 581.1. And V1 is going to be somewhere around 7750. All right, so let's see. I don't think we have a special maneuver checklist. No, we don't. So when I say maneuver, I meant orbiting checklist, which means we're now looking at our atmospheric entry checklist for the Earth. So the first thing to do is to check our alignment for a plane change. So let's take a look at our map here, and it's going to be a while. That's okay, because it's actually the middle of the night. I was hoping to land during the day, and it looks like we're going to get our wish. So we just have to wait for Earth to rotate us under here. So it's now April 30, 2033. So I can't look at that doing something like that right now.
Off.
So I'm going to have to disable RCS. We'll turn the beacon on now because we're in low Earth orbit. Not expecting anybody to show up here anytime soon. But so the next thing that I'm going to have to do is start looking at solving my re-entry thing. So let's start looking at the re-entry checklist. Okay, and when I said checklist, I really mean calculator. So let's take a look at re-entry solver 2A, and we'll get our apogee in. Let's see, right now that's, I think that's expecting, nope, that's expecting kilometers above the surface. 294,000. Planet radius 6378. Interface altitude is 100 kilometers. We can try a starter eccentricity of, well, that 0.1 is really high. Let's try 0.05. Our current inclination equatorial, 58.36. Argument of perigee is 76. We'll have to change that later. And we'll assume that the true anomaly, we're going to do a apogee descent. Rotation rate for the Earth, 86,400. And the planet mass, 5.98 times 10 to the 24th, the massive cone. Okay, now the next thing that I need to do is take a look at which one of these intersects 100 kilometers and note the angle here. So we got an angle of about 2.5 degrees. I think I normally shoot for 2. So we're a little bit steep. Let's try 0.04 for the eccentricity. Take a look at 100 kilometers now. That's 2.2. Okay, so do it again. 0.03. And now we're showing 1.4. Okay. 035. Whoops, I was looking at the wrong number. It's this one, 1.98. Close enough. Alright, so now we come over to the solver 2B, and let's see, this is Earth, 9.8. The gas constant set right. We need to change the pressure, 101. It's set for Titan right now, 101,325. Density, 1.225. Temperature, 288 Kelvin. This doesn't change because it's the ship. Again, part of the ship. Alright, now the mass. Current mass is 26581.1. Velocity pressure limit is a hard limit set by us. The profile is something set by us. Flight path angle we're going to use is going to be 1.98 from the first solver. Ground interface velocity we'll grab off of this as well. There it is. It's this F column. So we'll take the average of these two guys. It's going to be 7825. And our initial range, we need to add the range that we have on here. So we average these two guys. Yeah, ground range. The initial is 7974. And that's in meters. So 7974000. Alright, let's take a look at what we got. So we're going to come down, and when we reach about 90 kilometers or so, we'll perform our pitch maneuver. We're going to see probably up to 1.8 G's of deceleration. And we're going to see a peak heating of around 1400 C. And our velocity will decrease. We want to take a look at our range now. So the range is... that's going to be this guy. And we want our altitude, and that's going to be that guy. So let's look, and for it to come down to 30. Actually, I want my speed too. So the speed is this Vx, Vy. There it is, it's V. It's in the I column. Alright, so we'll get down to, let's see, 4 kilometers per second. 3, 2, 1. Okay, there's dropout, right about there. So we want, let's put about 30 right on top of the base. Right there. So we've got a total range of 12,940 kilometers. That's our range. Alright, so at this point we're just going to fast forward until we get to be able to see how close our ground track is to see if we need to perform a planar alignment burn. And we're done with encounter or transects for the entire mission. So we'll go ahead and configure for Earth orbit. Alright, we'll go altitude-wise for orbit. Alright, I'll see you guys in a couple sim hours when we get in place of our base. Okay, one of the most painful things in this game is fast-forwarding in 1,000 times X over low Earth orbit. The sim crashed like 3 times. It was terrible. Okay, yeah, we're going to need to do a little bit of an inclination adjustment. It's not too bad, but yeah, we're going to have to do one. So what we're going to do is we're going to go to Align Planes, and I want to target... oh, that's dumb. You can't... That's really annoying. Okay, well, in that case, once we cross the equator at the node here, we're going to burn... Let's see, it's a... I think it's an it's an ascending node, and we want to increase the inclination, which means we'll be burning orbit normal plus. Alright, so we're going to set up here.
Rotation.
We need to turn... Oh, we're still... Yeah, I need to turn green. There we go. Orbit normal plus. And get the numbers in. We're getting really close. Oh, I already pre-populated these. Let's see. It's nice to see city lights down there. It's like people are actually here. 26,580.7 will be the start. It's going to be like 7760. And then V2 above here, that all needs to be, that's just a straight copy down. 26,581.1. So we should, good, 0 show up. 7761 now, and I think we're all set up. So, oh no, wrong typo here. 26,580.7. There we go. That would have really scared me afterwards. I'd be like, I burned how much? But no, it doesn't matter. We're pretty much here. Okay, so we're at the equator passage right now. So we're going to begin the burn now, and I need to get my track display up here. This can sometimes take a few seconds to update, so I'm going to shut it off now and let it settle, see what it wants to do. Okay, looks like we're going to need a little bit more. Alright, I'm going to shut it off, see what it does. A little bit more. Done. Alright, that's pegged. So, we now have an orbit that will bring us to Wallops Flight Facility. This burn is completed. V2 7774. Then we've got final mass 26512.0. We use 948 meters per second, so 2/3 of our maximum allotted. So not good, but not critical. And the current mass that we have left, 59.6 kilograms. The initial mass of the ship for the next burn, 26512, which is ideally the last burn. Velocity is about 77-75. So let's see how much margin we've got. On the last burn, we've got 51 kilograms remaining. And there we go. So we've pretty much come down to the end. We're not quite at the very end, but just about there, just above the amount that we plan to use, plus the amount that we, the amount that we calculated we would use versus what we plan to use. All right, so let's quick save, and now we're going to come back to the orbital calculator here, and I want to do. Let's see. Go back to solver 2A. Make sure our apogee is in there right. So we are going to be. We're going to be about halfway around the Earth, so it'd be fair to use our apogee. So we can use 328,500. 637,800. We'll have to come back to that. We're now up to 65.38 degrees. Argument of perigee 48. True anomaly we'll assume is at 180. Alright, so let's see how this changes things. Going back down to 100 kilometers, we're still at 2 degrees. So this is acceptable. However, the range is probably going to be a little bit different. So we're going to come over to 2B now. None of this changes. That doesn't change. That doesn't change. That doesn't change. This changes. 26512, and it's 0.0. That doesn't change. That doesn't change. This changes. It's I think exactly 2 now. Yes, it's exactly 2. Interface velocity. Let's see. Take the average of these two guys. We're now showing 78.48. And the initial range, take these two. It is over 9,000! 9,001,000. Let's take a look at these again. 90 kilometers, 1.8 Gs, 1400 C. And the final range, so the first range is 9,001. The second range is going to be, so we need X. X is the range. So X, and we follow I for velocity. So we generally want about 30 kilometers to be where the base is. So we're going to begin our burn 13,959 kilometers from base. So how far are we? We're actually just one orbit to go. So we're getting close, and thank goodness it's going to be daylight, so we'll have a nice re-entry show, complete with blue atmosphere, everything to greet us. In fact, I think we can see Walt. I have to turn that off because it's gonna. YouTube loves to get me. There we go. Let's see, we're heading northward, so we should be over this way. San Juan, Salvador, Bermuda. Back there. Where the heck is it? Oh, no, we can't. We can't. It's going to be like right out that way, I think. Or no, out there. Yeah, out that way. Okay, so it's time to start getting real for re-entry. So we're going to target spaceports almost down to the bottom. Wallops Island. That gives us our distance readout. Now, of course, the Earth is only 40,000 kilometers in radius. Oh, but we're doing 14,000. We're fine. Just wanted to make sure that we're not looking for something that's greater than the length of the Earth, in which case I have to add half the Earth onto that. Okay, so, man, that's a mouthful. What now? Oh yeah, continuing with our checklist here. Orbit before re-entry. Solve atmospheric entry orbit for re-entry solver 2A. I did that. Solve atmospheric deceleration range per entry solver 2B. I did that. Add ranges to determine the distance from base to burn. The distance from the base to burn is 13,959 kilometers. Use solver 2A output for burn plan. So I need to solver 2A output. So it calculates my velocity. So I've got V2, which is 7576. So all I need is V1. So that's my V2. So for V1, I need, let's go into VisVifa, change this to Earth. I'm surprised I didn't have to do any calculation for the sun this time around. Our A is 6.652 times 10 to the 6. Radius is going to be 6.689 times 10 to the 6. So V1 is 7701. Okay, so doing a little bit of subtraction here. I forgot this is going. You can do the subtraction here. Alright, re-entry burn. Forecasted at 7701 minus 7576, 125 meters per second. That's slightly more than I budgeted for. We'll need about 8 kilograms to do this burn, which means I've got 60, so I'm good to go. So with a 125 second, 125 divided by 22 meters per second is about what we're putting out. So that's going to take roughly 6 seconds. So we want to do this 3 seconds from 13,959 kilometers. Begin re-entry burn at, we're moving at 7.7 kilometers per second. So that's going to be 23 kilometers added to 959, which means $13,982 begin burn. $13,982. Going back to the checklist, configure right MFD map, target base, that's done. A few minutes before the burn time, return or rerun both solvers for final plan. Okay, so we do need to do this one more time. I'm going to probably run the solution off camera and I'll let you know of any changes that come up. Okay, so the solver's been run. The changes are 8846 to descend and 13804 to re-enter. The velocity should not change because that only changes things by 100 kilometers, which is almost nothing. So we can now go into one of these magical things here for base sync. We're going to target Wallops Island, not Wallops, Wallops Island. And there we go. So there's our distance. So we are only two kilometers off for our what's the word I'm looking for? We're 2 kilometers off of our transverse, you know, like left right versus coming straight over top of it. There's no need for that. What does this ED thing do? It doesn't matter. That just changes things. What does ENC? Closest passage. Number of orbits to display, just 1. That's fine. It's not needed. Re-entry angle. There we go. 2 degrees. Re-entry anticipation degrees. I don't know what that is. Reference altitude 80. Alright, what is this doing? Oh, okay. It's giving us a delta V. 111 meters per second. And we use direct mode afterwards to synchronize. Okay. So I think what it's doing is when we get to the gray line, supposedly that's when we do it. If I change this to 0.
Hover doors are closed.
Yikes, I did not want to do that. What does 4 do? I wish I knew more about how this system worked. All I know is I can use it to check. The other thing we can do is go to the aerobrake MFD, which is the other one that I'm going to use. So I've got a triple alliance going, right? I've got my calculator, I've got aerobrake, and I've got base sync. And between the 3 of us, they're going to get me on the ground, on a runway. There we go. Okay, a few minutes before the burn time, rerun both solvers for the final plan. We can consider that done. Check airlock doors closed. Airlock inner, outer doors, and nose cone are closed. AF control surfaces pitch. Yeah, we can do that. Wait, no. That's going to require that we... That's a mistake. Because that's going to require that we power up the... APU. We can't do that. All right, left MFD orbit. Let's keep an eye. We still got 4,000. Right MFD aero brake and target base. So aero brake, target, Wallops Island. I should have done this on the other. There we go. Slew to burn attitude. So that's going to be retrograde. And the word of the day is eccentricity. That is, we're going to lower our eccentricity of the orbit to 0.035. And that's how we know when to release the engines. Go back to map, see how... actually, we might be able to get the distance. Can we get our current distance from base here? Doesn't look like it. Alright, then in that case, we have to monitor the map. Ooh, we're at 15. Okay, we're almost there. At 13,982, which is basically 14,000, we have to start the burn. And don't miss it. I can't miss that. Let's get the numbers in real quick. Alright, for the re-entry. Fuel before this, 59.6 kilograms. Initial mass is 26,511.8. V1 is 7698. And then we're just ready for V2. So we're pretty much ready to go. So we've gone to our burn attitude. The next step is to perform the deorbiting burn. So that's it. We're going to sit and we're looking for 13,982. Okay, we're getting pretty close now. One thing I can do is calculate my V speeds. So I have this other document that shows this. So we are at we're at 26,000. So we'll average these two, which means our 3-degree glide slope V rep is going to be 145. Quick, write that down. 145, and that's a indicated airspeed. And don't forget it. All right, we're coming up. 13,982. Begin the burn. 13,982. 13,982. I can't say it enough. 13,982. So we're going to see 13.98. I see 13.98. You burn. 14.0. 13.99. Burn. 0.035 we're looking for. 3.1, 3.3, 3. .35. Okay. V2 7590. Get back to this. 7590. Current mass of the ship 26,503.5. And if I've done everything right on this re-entry, that is the last burn in the entire mission. we've made it. All that I have to do now is re-enter. So, going back to the checklist, that's been done. So now we need to slew to the re-entry attitude. So we'll turn prograde. And we're going to check against our other solvers here. So let's go to base sync. The ship must be on a circular... Oh, right. So we want to use direct mode. How do we get into direct mode? Ah, there we go. Direct. So is this going to tell me? Okay. Well, I don't know how that works, but I can try aerobrake. I know how aerobrake works. Let's see, we're too shallow right now. We need a steeper right there. Okay. Let's see what we look like. 1.8 Gs. And it's really Gs this time. I thought there was a way to get it to display like the heat. Okay. All right, so it looks good for aerobrake. Let's check base sync one more time and see if I can figure out how to work this thing. Went direct. What does this do? It says 7 kilometers. I'm not exactly sure what this is doing. One orbit. All right, so we're go to continue. Let me check solver 2A now. So we want to cross-check this. So to do that, remember we said we needed 13,982. So what we need to do is figure out how far we've gone, subtract that out, figure out what our altitude and velocity should be, and read that out. So, ground range from the burn, we're at 2,200 for the range, and that's kilometers? No, it's not. 2 meters. Or, sorry, kilometers, yes. 2,300-ish. So we should be at about 300 kilometers. We're at 280. 280 says we should be 3,200 kilometers. 14. So we might be going down a little bit faster than anticipated. Let's see what our velocity is. 74.35. Okay, so we're going a little bit slower than anticipated. We're coming down faster. Okay, so what that means is we're going to have a gentler re-entry. So that's fine. We're still looking okay there. So we're good. Cross check. Oh no, we're going to set the radios for landing. Okay. So I want to come over to comm nav, and unfortunately you're not going to be able to see this, but I'm going to go to object info, spaceport, and I'm going to go to Wallops Island. And the runways, let's plug in all the runways, just in case. So the only ones that we can really use. We're heading eastbound, so let's try for 27. No, 09er. Let's try for 09er first. 124.3. Point 1, point 2, point 3. The next one we can try is for 09er. Or sorry, 27. 124.2. Point 2. Then we'll plug in 21. Actually, let's plug in 3, since 3 will be what happens if we come up short. Actually, let's plug that into nav 2. 124.1. And then our other option is 27, so that's 124.2. 0.2, and we've got one more that we can set. What do we want to use? Let's see, we've got 24.3, 24.0, runway 21, 124.00. Alright, so the prime runway is going to be 124.3. That is 09er. The backup runway is going to be 124.1. That's if we're coming up short. It's the longest runway, so 03 is our best hope for that. So now what we're going to do is we're going to go over to HSI. Where is it? There it is. And we're going to do nav 1, switch this other guy over to nav 2. This is, and to remind us, we're going to do runway 09er. And this one, oops. This one we're going to do 03. And hopefully that should remind. Okay, radios are set for landing. So we're going to want to cross-check again. Let's go back to the map here and begin to start zooming in. Let's take a look at actually, I'll move this one over to aero brake. Okay, cross-check again looks good through aero brake. I'm going to cross-check one more time against my solver. So we're now at 237 kilometers. That says that we should be 5,300 into our journey down. So 5,300 minus 13,982, and we were at 9,500 for reference. So 2,8, doing some real quick paper math here, 8682, and we were at 9,500. So we're coming down. Actually, that looks slow. 80. I said we should be at 8682, and we're at 9,500. Oh yeah, that means we're coming down fast. Yeah, so it'll be a little bit of a shallower burn. Okay. All right, so I say we're still good to continue. So let's start getting this stuff set up. So we want to know when we're 5 minutes from the re-entry interface. we take a look at the angle here. So we hit 100 kilometers. Let's see, do we have a time? No, we have a degrees ahead. Does 2B have a time? It's got to have a time. Yes, it has a time. Okay. So we start at 3:01. Let's see if I can find it. It's at 100 kilometers. There it is. Okay, so 1041, 5 minutes before re-entry would be 7:41. At that time, our altitude will be about 117 kilometers. So we've still got a ways to go. All right, so the next activity is at 5 minutes before re-entry interface. Should start to see the dawn light of Earth. Yep, there it is. All right, see you in a few minutes. Things are going to start really heating up. Okay, so we're at 130 kilometers now, and I will say that the really nice thing about where we're coming down, if you take a look, our orbit line directly overflies the east coast, and there's like 1, 2, 3, 4, 5, 6, 7, 8, there's like 9 or 10 bases here that we could, in theory, make if for some reason something goes horribly wrong on my descent. Alright, 5 minutes from re-entry interface, we're here. Here comes the last critical operation for APU. APU on. We're going to turn AF control surfaces to pitch now.
Pitch.
Retro door close. Hover door closed. Radiator. We're at 117 kilometers. At this point, we must stow. And begin our temperature rising. Okay, the re-entry is closed. Perform the re-entry check. Display 9.
Re-entry check. All systems green.
Excellent. Alright, at 2 minutes from re-entry interface, which is going to be, it's roughly linear at this point, so 117 kilometers is going to be, let's see, 5 seconds down to 100. That's now. 100, re-entry interface is at 100. Alright, degrees centigrade. Display 2, set angle of attack 35 degrees. Display autopilot. And we'll move to display 3 for the temperatures. We're going to switch over to our re-entry secondary HUD. And we're going to turn, yes, the HUD is now on, main HUD is now on surface, and we're going red. We're entering the Earth's atmosphere. Secondary HUD has been set. Left MFD to surface. And we're going to do right MFD to aerobrake. We're going to pitch to intercept the target vertical speed. Our vertical speed is on the surface display. That's 75 meters per second. Once the target vertical speed is reached, we're going to pitch the craft to keep the aerobrake MFD target centered as ship limitations for temperature and G-forces allow. Here we go. Okay, the heating event should be starting momentarily. We're now past 100 degrees Fahrenheit, and in just a minute or so, we'll be red hot. Okay, the deceleration has begun.
Mach 26.
I
Mach
can hear
25.
the atmosphere now. Coming up towards El Salvador. Okay, we are very hot now. We're at minus 126.
Mach 24.
So we're coming up on our target BS. Above 1,000 degrees centigrade. Yep, we're starting to turn color. Alright, now we're pitching up to, let's try 45. Actually, that's too much, too much. Let's try 37 and a half. I'm
Mach
very concerned
23.
that we're going to come up short here. We might bounce, but as long as we leave everything where it is, we should be okay. Aero brake is really good about what it does. Alright, I'm going to recenter and zoom here. Okay, we're bouncing out of the atmosphere now, as intended. Okay, we're showing that we're coming up short, so I'm going
Mach
to
22.
adjust my re-entry angle here to extend. Alright, the other thing that I'm going to do while I still have time is get a calculator together for 3-degree glide slope. So I need distance from base,
Mach 22.
altitude to match
Mach 22.
3-degree glide slope. So if we just say a random distance in kilometers, so let's say we're 100 kilometers, that's going to be it's
Information.
A times
APU fuel 40%.
tan, yep, 40% APU fuel, that's fine. Radians of 3 degrees. Okay. Perfect. So 100 kilometers from the base. We want to be 5 kilometers in altitude. Something tells me that that's not a 3-degree glide slope. Yeah, that is. Okay. Well, we've had our mini apogee here, and we're going to go back into the atmosphere. Let's see, we might need to decrease our angle of attack just a bit more here. Actually, I don't want to plunge in too steeply. That's not a good idea.
Mach 21.
Alright, so if we need fuel and I need to cross-feed it over, I'm going to cross-feed over using this control here. We'll cross-feed towards main. Alright, we're now, looks like, over Cuba. Oh yeah, there's Havana. So there's the first
Mach
base.
20.
That's the first in a row of 10. Wallops should be halfway between the two. Alright, we're at a very high vertical speed now, so I can shallow the re-entry angle a little bit here, get a little bit of glide distance. Check out the temperatures, they're coming up again. Coming over the Florida Keys now. Alright, I think that's bought us the extra distance that I wanted to have here.
Mach 18.
I don't even need a map anymore. Coming over Tampa. Actually, that's Sarasota. Tampa's up here. Alright, zooming the map in again. So we got Miami. It's coming up the next
17.
base. We have the most nearest base displayed here. Alright, I need to get back to aerobrake. We're still showing 20 kilometers. Had peak heating, now decreasing. 1300 centigrade, not bad. So that was only about 100 degrees off of my estimate. And we are coming down a little bit steeper than I expected. We bounced out. So that would shallow things out. Alright, here comes Cape
Mach
Canaveral.
16.
That's the next one in the line. Still showing 14 kilometers from base at Wallops Flight Facility, now 13. Still looking good. Coming down, we're now to 5 kilometers per second. We've burned off 1/3 of our orbital speed, and I believe at this point we've passed our maximum heating levels. Still at 13 kilometers to go. Now passing over Cape Canaveral at 5 kilometers per second.
Mach 15.
Okay, 14 kilometers, and I need to see, are we to start zooming in? It's really hard to tell whether we're coming ahead or behind. There's the heat, 1.2. So it's going to go back up again, but not as high as it was before. All right, let's see. Up to Jackson. Yeah, Jacksonville. The Florida-Georgia line. I'm calling this stuff off for me, just so that I'm keeping track of, like, okay, do I want to be going 4.5 kilometers per second at the Florida-Georgia line? Yeah, I think I do. So we're at 21 kilometers. We might be falling a bit too fast here. Yeah, we're falling too fast. Okay, so I'm gonna shallow the angle here. Back above 1,000 centigrade, we're going for our third reheating period. I think we're coming up to southern South Carolina. Yep, Charleston, Wilmington. Actually, that's North Carolina. So we're almost to Myrtle Beach. We're at 4 kilometers per second still. And it's probably time to zoom in again. Not quite yet. Alright, nearest base still says Cape Canaveral for some reason. There's no way. We're way closer to Charleston International. Not sure why it's doing that. Maybe it's only bases that are coded into orbit. Okay, now it's time to zoom in again. Go back to aero brake.
Mach 12.
13 kilometers. We're looking good. Let's check on where we are. What is that? Cape. I forget what that is. We should be near, yep, the Outer Banks. Okay, we're getting closer. Still looks good. 13 kilometers. We're pretty stable right now, I have to say.
Mach 11.
Killed off half of our orbital velocity here, still showing 13.8. Alright, I'm going to switch the ground speed over here over to indicated airspeed. Remember, I want my VREF at 145 meters per second. Okay, we should be getting close to, what is it, Greenville? I think so. Alright, we're coming up to Norfolk. Alright, Wallops Island is in visual range. We're getting close to dropout now. Still showing 16 kilometers. Might need to shallow. Yeah, I'm going to have to shallow the angle one more time. Have to watch that wing stress, though. I don't want to overdo that. Okay, and then let's go back up.
9.
There's not much needed at all. Okay, we're almost done with aero brake here. We're going to zoom in one more time. There's Wallops again on level 64 zoom. Let's go back to aero brake. Still showing 13 kilometers, and zoom this the heck in. Okay, we're almost to the Virginia state line. I can see Wallops Flight Facility. It looks like it's coming into a very good position. Again, rambling to myself so that I know what the heck I'm doing. Okay, getting a little bit too shallow again. So I'm going to continue shallowing the angle here. Okay, we're coming into Virginia. Should be over Naval Air Station Oceana. There is the Great Dismal Swamp. And heading over the eastern neck of Virginia. Okay, now it's saying that we're going further than expected. Okay. Right about there. Maybe half a degree less. And I can start to see the Earth's atmosphere is starting to turn. Starting to turn blue. And here is our runway, right there. Okay, we are getting really close to entering the approach phase here. Dropout should be happening pretty much momentarily. We're now down to an indicated airspeed of 480. I'm looking for 145 to exit stall. Okay, now down to 360. Below 1 kilometer per second. I'm going to now introduce a 5-degree right bank. Okay, we're coming down now. We're at 200, 250. We're below 100,000 feet. I'm going to switch over to HUD 3. We're at 73,000 feet. At dropout, secondary HUD 3, cancel re-entry autopilot. So, at this point...
Mach 2.
Yep, we're below Mach 2 now. So, at this point, I'm going to very carefully start decreasing our angle of attack, being very careful not to cause a wing stress event. I do want to come out by the time we get down to about 50,000 feet, so we're getting close to that right now. Okay, we're down to 170 meters per second now. Quick save just in case. And we're coming out now. Okay, we're down to 155, getting pretty close to our target of 145. Alright, there's 145.
Subsonic.
Alright, watch the wing stress. Okay, that's it. It's over. Set angle of attack to 0. Disengage, set back to pitch. We're going to go to Fahrenheit, and we're looking for 145 for our indicated airspeed.
Off.
RCS
on.
off and AF control surfaces on. Okay, at this point, re-entry is finished. We're going to go over to our, what is it, aerobrake MFD? No, we just finished. HSI. Runway 09er. And start using my other calculator. So we're currently at, we're at 12 kilometers. Where is this thing? Yes, we're at 12 kilometers in altitude, which means I have something like 200 kilometers to fly. That's my range. All right, we're at 139, 140. Let's keep an eye on that base. 143. Indicated airspeed 144. Okay, we're just about there. So once we swing around, we can use this glide slope indicator to help us out. So we're now at 9 kilometers. So we have, I think, 170 kilometers to go. That's our maximum distance that we have. All right, stay on top of it. 150 to 8. It's showing that we're only 12 kilometers away. Yeah, I guess maybe that is true. The suspense is killing me. I really ought to create like one of those. Space Shuttle had a descent. It had a descent table. I need that. Okay, we're now down to 7 kilometers. That means I have about 130 kilometers that I can fly. Almost there, not quite. You can see the Potomac River here, Virginia, southern Maryland, Eastern Shore of Maryland, and northern neck of Virginia, and rest of Wallops Lake facility there. Alright, it looks like it's time to turn around, so I'm going to do that before I can't. Okay, we're above glide slope, and that's not a bad thing, honestly. So, we're on
5,000.
final approach now. We should be good on altitude at this point. So, we're moving on to our next checklist item. Oh shoot, there's a landing checklist. Glide path angle, final approach, extend gear, max 39 meters per second. It's going to balk at 30.
4,000.
Yes, 39, and we are at 15.
Gear down.
Good to go. Final approach. If we need to, we'll put it up, but I think we have
Gear
enough
down
to
and
make the
locked.
runway at this point.
$3,000.
Alright, one more quick save. I have had it crash before on landing. Gonna get ready on the wheel brakes. Alright, gears extended. VRAF 145 after touchdown, braking is needed.
2,000. You are cleared to land.
Alright, let's use a little bit of rudder here. We're a little bit left of the runway, a little bit high.
$1,000.
Alright, hand is solidly on the joystick.
900. 800. 700.
Pretty sure my heart rate is
600.
like 300, not 300, 180 beats per minute.
500. 400.
Come on. Get over there.
300.
Alright. Still doing VRAF.
200.
Looks good.
100.
Approach still looks good.
75.
Alright, here we go.
50.
Final.
30.
Here's the landing.
15. 6.
Oh shoot, we bounced.
6. 5. 3. 1. Touchdown.
There's touchdown. We're going to add full wheel braking. We were kind of late on that touchdown. Come on. Come on. Stop on the runway. Stop on the runway.
100 knots.
Okay, we're... Well... just off. Okay. So, we're not slowing down anymore. I wonder if
Wheel
we had
stop.
a little bit of a glitch. Yes! It's over! We're back on Earth. Oh man, I really want to play the Celebrate Good Times song, but if I do, I'll get C indeed. That stinks. I forgot to turn the nav lights on. That stinks. Okay, we're done. So they're on video, but just so we said in the beginning. So at the very end, we say at the mission completion. V2, 0. Then we need mass final. $26,468.0. And of course it's going to get rid of that 0, and then we'll be like, you didn't get the decimal point. Oh, but I did. It just happened to be 0. And then last, the fuel in tank. And I have to get this right because as soon as we taxi, it's going to go away. Alright, 51.3. V2, 0. Mass final. 26468. 26468. Yes, that's good. Fuel in the tank, 51.3. So I'm going to take a picture, snapshot here. We should have
Information.
all the
APU
information
fuel
that we have.
30%.
It doesn't matter anymore. It doesn't matter that our APU fuel is low. So guys, would you agree that we have not had Earth's atmosphere in the craft in a while? How about we open that cabin hatch that we haven't been able to open?
Using external O2.
Very nice. First time ships directly open to atmosphere. Okay, where the heck are we going? Alright, that's our hangar right there. So we went into the overrun area. While we're taxiing, I'm going to bring up Google Earth, and I should be able to show this on screen. I'll show you what that overrun area looks like. I think we would have been okay. Anyway. Alright, let's see, our final margin is exactly 51.3 kilograms. That's what we're walking away with. We can go to airspeed, and we'll set for 5. Go over here and engage. Should have just enough fuel to taxi over. Let's get back on the taxiway here. We've been off-roading since we left Earth, so I'm not really worried about that overrun. To be honest, I was a little bit surprised that we bounced the way we did. Like, I know I came down pretty quick and pulled up hard on the stick, but what really surprised me was the fact that we bled off like a good 40 meters per second of airspeed. I like to think of it as the floating Cessna scenario. I don't remember this ship doing that. Alright, let's bring up Google Earth. Okay, yeah, we're still going. Hopefully this shows up. Alright, so if I zoom in here, you can actually see, I think the glide slope, and I think we went right off here. Yep, terrain is showing. So between here and here, a nice mode field, and we lose 1 foot in elevation. No obstacles, and then we swung around this way, got back under the taxiway, and off we went. So yeah, if this happened in real life, we would have had absolutely no problem. Guaranteed. Okay, so once we, I will take one more set of numbers here. Once we get back to the hangar, we're going to unload everything and stop for the day. Because remember, we're not putting the bow on until next episode. Next episode is to take everything and put it all together in one place. Also, I think that was the first time I ever did a complete re-entry with 0 fuel and didn't need to open a speed brake. I'm glad it's this time, because this is when it really mattered. We did not have the fuel for a 1,000 kilometer airplane ride. I love our strobing engines there. They're just turning on and off. So I'm going to get the final masses once I get the APU powered down, because at that point we're not consuming oxygen, we're not consuming APU. The mass of the ship will be fixed at that point. Alright, here's our turn. Let's bring our airspeed down to 2. Alright, and there. Let's bring us to a stop. Oh man, it didn't say wheel stop. It's kind of anticlimactic. Anyway, here we are. So, at the no, we can't do that yet. Okay. Last one. Shut down. AF control surfaces off. RCS mode off. Tertiary HUD off. Secondary HUD off. Primary HUD off. Temperature display. Now let's go reset this. Degrees Fahrenheit, good. All MFDs off. Oh.
Pitch on.
I should have said to reset the elevator trim. There we go.
Pitch off.
Okay, nav, beacon, and strobes off. Mission elapsed timer note. Here we go. Okay, we'll get this down. Final duration of mission. 4,035 days. 14 hours. 37 minutes. And 48 seconds. The mission is declared complete at this point in time. Okay, cabin hatch is desired. We've already opened it. Jeez, this ship is beautiful. I'm so happy I brought it back to Earth with fuel to spare. Okay, nose cone, open. First time ever since we left Earth. Outer door open, and at the same time, inner door open. We can see the grass of Virginia. Very nice. Bay doors as desired. We have lots of cargo to unload. Let's open it up. Payload camera view. And that should be the last time we need to use the APU. And our ship mass should now freeze. APU off. Grab our final numbers now. B2, 0, mass final 26449.231 kilograms. Fuel left in the tank at the hangar, 44.1 kilograms. That's not the final margin. The final margin was 51.3. This is unplanned travel that we're doing. I mean, it's planned, unplanned. Give us a tow, for God's sakes. Okay. Payload camera view. Oh yeah, one more thing we need to do. External cooling on. Because we're almost at 70 degrees.
Hatch open.
Okay, O2 is frozen because
external
everything's
cooling
open,
online.
and we're quickly cooling. So that's it. We've got the EPU attached. So we're non-time critical. Let's go out to the payload camera, and we're going to deploy the cargo. Should show up right there.
Payload deployed.
Excellent. We have emptied out, so we'll go ahead and close the bay. Actually, we don't need to close the bay doors. We're going into the hangar now. All right, return to the upper panel view. Then we... I think we're done in the ship. Yeah, we're done. All right, everybody off.
Egress successful. Egress successful. Egress successful. Egress successful.
That's it. We're done with the ship. Just in case.
Analyzing.
Always do it.
Atmospheric pressure nominal.
Yeah, that's what I expected. Just checking. Just checking. Okay. All right, let's go over to our payload rack here. And let's see. I think I called it SHIE01 or whatever. Or is it? No, it's UGCR payload adapter. Shift C to release cargo. Oh, cool. You can see me. And everybody else over there. So Shift C 3 times, I think. Oh, not Shift X, Shift C. There we go. Shift C. Okay. All 3 cargoes have been unloaded on the tarmac. Go back to me. And put me in my final position. We'll opt for the awkward Mr. Bean... the awkward Mr. Bean New Year's party formation. Let's get Galileo.
Analyzing. Atmospheric pressure nominal.
Okay, so for Galileo to take his suit off too.
Analyzing. Atmospheric pressure nominal.
Okay, so I should note that not everything's coming back. And by that, I don't mean consumed fuel and consumed oxygen gas. By that, I mean we obviously sent the probe into Saturn's atmosphere and
Analyzing.
it disintegrated.
Atmospheric pressure nominal.
That was the one thing, that was the one non-consumable that didn't come back. And it was intended to be that way. That was the whole plan all along. So yeah, this is the end of the mission. This awkward formation. We're done. This looks so weird. I love it. Their shadows look like Stonehenge too. Looks like it's about 8 a.m. Yep, 8 or 9 a.m. Oh, it's April 30th. Okay, so it may or may not be warm enough for the beach. So, okay, making sure we have everything at the end state because I want to make sure that we leave this as beautifully as we can. I'm going to go back to selecting Dr. Aeronautics because that's how I think it began. Alright, so we have one XR2 Raven Star. We have one life module, one control module, one flag kit, and one disintegrated probe on Saturn. We've got 4 people: Dr. Aeronautics, Giovanni Cassini, Galileo Galilei, and Johannes Kepler, and we've got the empty payload adapter. That's it. That is where we leave this mission. So if it was warm enough to swim, I can show you guys the beach. So once you get out, there's a highway that runs up alongside here, Route 175, Virginia. That runs out over a causeway over here, and that causeway runs out to the island of Chincoteague. And the island of Chincoteague is this gray spot that you see right here. You go through Chincoteague, then there's another marsh. You go through that marsh, and then, oh, wait a minute. No. There it is. That's it. So this is the causeway. This gray thing that you see here is the causeway. Okay, that's Chincoteague. Then you cross the water where this is where the famous pony swim happens. And this is acetate. And then this strip of sand, that's the beach. All of this is accessible out to this hook, which is called Tom's, I think it's called Tom's Point. This is called Tom's Cove. Great place to kite surf in. And just so that you have a wider appreciation for where we are, you know, New Jersey, Pennsylvania, Delaware, Maryland, Virginia. Yeah. All right. We got to call it at some point. So we're gonna come back for one more episode where we basically crunch all the numbers and capture all of the artifacts, as we call them, to end the mission. I've been Dr. Aeronautics. Welcome back to Earth. I hope you enjoyed your flight. See you next time for our debriefing episode. Bye-bye.